All right, what's up, everybody? Welcome to Jupiter Brain. My name is Joshua Torres. Unfortunately, we are missing my co-host today, Albert Chin. I guess he was sending off one of his friends. I guess for the end, he was going home or something for the break, so he couldn't be here today. So I'm super pumped you guys are here today. So we have Alex Matseko, which is a mechanical engineer, and then Connor Westfall, electrical engineer. So today we're essentially just gonna have fun, right? And then we're just going to maybe talk a little bit about what we learned over the semester. I really don't think we get enough of that, right? Me personally, they say you should be journaling about things that you learn through your life and whatever. You should reflect on these big moments in your life, right? Which I think the end of a semester should for all of us be a huge moment, right? Like it's a sense of accomplishment, unless you just failed every class. But
gonna find out.
Yeah. But so anyways, we like to say here at Jupiter Brain that we are philosophers or engineers by day, philosophers by night. So like sky's the limit on the topics to talk about. Just like I said, the overall theme will be sort of like what we learned during the semester. So we can talk about whatever, but I would like to ask you guys some questions about some of the things you feel you learned, things that you got from this semester, maybe some some like big hurdles you went through, stuff like that. So if you don't mind, Alex, could you just sort of say like where you're from and like why you picked mechanical engineering when your research is in biomed?
It's definitely interesting. So I was actually born and raised in Midwest City, Oklahoma.
Okay.
I chose to go to UCO because it's cheaper. And I love that I get to actually meet the professors. That's a big deal for me. The class sizes are small, which is really nice. So I actually initially just loved mechanical stuff in general, and so I always wanted to be a mechanical engineer. What kind of brought that into fruition was a book called Bomb by Steve Sheinkin. It goes over the Manhattan Project from the perspective of I think his name is Harry Gold. It's one of the Soviet spies, and it kind of goes into the physics of it and then the engineering side of it, and I just thought that was the coolest thing ever. And so from then on, I was like, I'm going to be an engineer or a physicist. Yeah. This is what I want to do.
Yeah. It's a huge project.
Oh, no, absolutely. Yeah, absolutely.
So much lore around it, so much history, so many interesting characters.
Their books are still being written about it because we're still learning new stuff about it. It's super cool. And then when I got here, I got into the biomedical project with Dr. Hassan. Initially, I hated biology. I didn't understand it. It wasn't as much of a formula to me. It's more abstract. But I learned to love it, and I learned to really just respect and enjoy all the biology research we do here at UCO. And so I've been helping to create stents to treat intracranial aneurysms, and it's just been really good. I've been able to go so many places and do so many things I never would have dreamed of. The opportunities here are amazing.
Yeah, that's why I try to get everybody involved in research. I try to say, hey, look, we've got to go to New Orleans, Palm Beach. Hopefully, I just. Applied to Incur for next semester, so that's in Virginia, I believe.
Richmond, Virginia.
Never been to Virginia before. Never been to all of these places that I've been for research. Well, except for Dallas and Oklahoma, right? But it just gives you a chance to like go and meet, for one, new people, but then also like people who are like you, like-minded people who are doing research in the same sort of field, and more like curious people, right? Which we get here at UCO. I wish there was more, but that's why I'm sort of why we started the podcast too, to just find those like curious people around us. So, Connor, do you mind doing the same thing? So just to talk about like where you're from and why'd you pick electrical engineering?
Yeah, so I'm also from Oklahoma, born and raised, and my undergrad was actually also in biomed. So throughout middle school and high school, I was really interested in physics as well as biology, and I found that dissecting cow hearts and sheep brains was actually really fun. And
Not for me.
when I went to college, and my college advisor was like, hey, look, the biomed courses, you get to combine physics, you get to combine biology, you get to combine electrical and mechanical. It's a grab bag of all the different disciplines combined into one. So if you're not sure which to specialize in, go here and you can decide later on. And I did that. And then COVID happened, and so I was like, oh, wow, so this is like the world telling me that biomed research is really what I want to do, because this is not a comfortable situation to be in.
A sign from the universe. Interesting.
But then in my...
Wait, you said that you don't want to do?
What I do want to do...
Okay. Sorry, I misheard you.
Like, I wanted to work on vaccines. But then in my capstone, I found that actually creating devices was way more engaging with my brain, with my hands, working with my hands. And so that's when I started pursuing electrical engineering for my graduate program.
Well, yeah, I mean, apparently we need a bunch of electrical engineers, right? If you think about what is happening right now with AI and having to build new electrical systems and new electrical plants, we're going to need more electrical engineers, right, out in the field, and thinking about how we can better use our energy.
Speaking of energy, fusion's right around the corner. Did you hear about the MIT? They made a tokamak fusion generator. Well, they're making it because they cracked the code on like really powerful magnets that they're using. So the tokamak generator, that's like real big in France. It's been 30 years with the beryllium shell. It's a diameter of about 30 meters. MIT plans to make one a third the size with the diameter of 10 meters. That'll have the same output with these new magnets.
Interesting. Tell you, magnets, man.
Magnets. Magnets,
my research is in essentially magnets or material science, but focus on magnets. And I don't know what it is, dude. It's so funny because, as a kid, you know about magnets, right? You play with them. They're all over the place, but you don't understand just how useful they are and how many different applications they're used, right? They're used in everything, right? And here I'm sure there's plenty of magnets in your phones and everything. And the whole earth is a goddamn magnet, right? Right? So it's just so fascinating. But anyway, so is this the book that you were talking about?
Yes, that's the book I was talking about.
Okay, cool. So I am sharing the screen too. So
that's fine. Yeah.
Anything you guys want to pull up or whatever, we can pull up. I've got this little Bose speaker that we can play stuff on or whatever. So if you guys have anything we want to pull up or whatever, feel free to just say, hey, pull this up.
Yeah.
But this looks like an action book. Is it more about the history of the...
So it goes over the history of the Manhattan Project from the perspective of several people. And so you can see based on each chapter that it kind of changes its perspective. So you have the first chapter, I believe, is Harry Gold, I don't remember his name. All I know is that he was a Soviet spy. And the book immediately starts with the FBI raiding his house and him getting arrested. And then when he's sitting down with the police is when he kind of just fesses up saying, here's who I am, here's who I actually am, and here's what I'm doing, and here's what I've got. And then he goes over, it's kind of like him sitting in the living room, and he's talking about everything he's gotten so far about all these people. And then it kind of goes into the perspective of some of the fighters and resistance fighters in the Netherlands. And then you get into kind of Einstein and where that goes with the letter to the president. And then it kind of just changes its perspective from all different cool people that, and some people didn't even think about and how they impacted the war and the war effort. And I just thought it was the coolest book that has all those different perspectives, because we always kind of see the Manhattan Project from one perspective, and we just think about the scientists and physicists, but we need to think about all the different sides of it and how important it was.
Did you guys watch that movie Oppenheimer?
It is my favorite movie,
along with Barbie.
Such a great movie.
Yes, I went and saw both of them. It was Barbenheimer summer. You had to, dude.
Yep. Absolutely had to.
Did you watch Barbie as well? Yes, let's go.
I wanted to go watch Barbie with suit and tie with the boys. That's what I wanted to do. Exactly.
Did you do that?
I didn't get a chance to. All my friends were busy, but I wanted to so bad.
Have you seen Barbie though?
I actually didn't get a chance to see it because of that. I was holding off just so I could watch it with suit and tie with the boys.
That's hilarious. Well, we're gonna have to set that up, dude.
Oh, absolutely.
Because honestly, like I thought was a really good movie. Like some people politicized it or whatever, but I thought if you just like look at it as pure entertainment, dude, it is pure entertainment.
Yep.
Like they didn't politicize Oppenheimer.
The
whole communist capitalist subplot of that.
Yeah. So hilarious. So, I get. So, we also like to sort of like talk about how our weeks went, and what better week to talk about how our week went other than like finals week. So,
literally, yeah.
How does y'all's weeks go?
I would say mine went better this semester than last semester and the semester before.
Okay.
I only had 2 finals because one of my classes, actually 2 of my classes didn't have a final. Probability and statistics, engineering probability and statistics. That one only had an optional final, and I was able to take it a few weeks before. And then for introduction to computational fluid dynamics, it's just ANSYS software.
A mouthful.
Yeah, it's a mouthful. It's just ANSYS software, so that one didn't really have a final. We just did a final presentation last week. So I only had 2 finals to study this week for. But I also had multiple projects to do,
That's
of
nice.
course.
Oh, okay.
So I had 3 projects this week, and I'm finishing one up after this podcast for Dr. Conacher and ME Design. I had to make a Sharpie impact tester and build it.
Sharpie impact tester?
It's called Sharpie impact tester. You can look it up if you want to. It basically just tests the impact energy required to break a certain material.
Impact test?
Impact tester, yeah. Sharpie impact tester.
Okay.
It's basically we had to make it within certain dimensions. The whole idea of this project was to make it within like 250 millimeters by 500 millimeters by 150 millimeters.
Is this it?
Yeah, it's one of them.
A Sharpie impact? Like I don't understand. Like what is? It's not like a Sharpie that we're thinking of, right? Like a marker, a Sharpie.
Yeah,
marker.
I think it's Sharpie, and I think it's supposed to be like the name of the person who made it.
Oh, Sharpie.
Yeah,
okay,
it's interesting. So you'll see.
You let me type in Sharpie.
Yeah, I was just Well, I actually did that initially too, and it autocorrected me. I was like, because Shart and Shart, they sound very so it's hard to tell.
Okay, so what does this thing do?
Okay, so you're gonna see on the bottom is gonna have like a little area where you put the test specimen. It's gonna be like any material you want. The Sharpie. Yeah. It could be anything. It could be Sharpie. It could be a highlighter. Whatever you want.
Yeah.
You're gonna cut a little notch into it to make it a little bit easier to break, and kind of make a little zone where it's gonna break a certain way.
Okay.
Typically, it's kind of like a little triangle cut. And you'll see up top, it's kind of you got like the pendulum arm, and it's gonna have a little weight on the bottom, kind of a little impact head that's usually pointed a little bit, and you'll see there's kind of like a little protractor on it. And so what you're gonna do is you're gonna drop it, and you're gonna know that you're gonna drop it at a specific height. And then you'll know once it hits the surface, obviously it's not going to go back to its original position.
Yeah.
And so that difference, you're going to subtract and calculate how much energy lost there actually was upon impact.
Let's see. I'm going to try to pull this video up here. Sharpie impact.
Yeah, you see a little notch in it, yeah.
Oh,
so it's just a giant weighted hammer.
Yep.
Interesting, but it's a hammer that takes measurements.
Yep, it takes measurements. So mine's gonna be very it's supposed to be very crude.
Is it gonna be like that?
Absolutely not. No, absolutely not.
That's a huge device,
It is a
dude.
huge device.
How do you even get that in there? You gotta like get a crane to bring that
Hammerhead is
monster.
probably like 50 to 100 pounds alone.
Oh my
I
goodness.
have no idea.
That is insane. Okay, cool. Interesting. Okay. Weird. So, what do you have left on this?
So, I actually need to make a test specimen. I ran into so many problems building this stupid thing. I hate it so much. So, one thing that really sucked that I ran into that kind of almost threw a wrench in my entire project was wood screws. So I built the thing out of treated pine, and I got wood screws thinking, oh, I'm screwing into wood with wood screws. These should be just fine, you know. I got number 8 with by 3-inch link. And
Connor knows.
Yeah, he already knows where this is going. So I drilled into it. These are solid brass wood screws. I think that's just a way to make it cheaper, I assume. I was thinking, okay, well, these are engineered specifically for wood, and I'm drilling into wood. This shouldn't be an issue. Shouldn't be an issue. Boy, was I wrong. I learned something this week. I learned that I still need to tap a hole into it before I start drilling wood screws, because I screwed right into it 3 times and broke the screw off inside of my base. And I couldn't get it out.
What were you thinking, dude?
I don't know. I thought it was a wood screw and it would drill in just fine. Nope. I broke 3 of them off because as you drill into something, more of the threads come in contact with whatever you're drilling into, and so your the frictional force will increase because of that. And so as it went in, it was just going more and more and more until there's a torsion fail where the screw just completely rotated and just broke itself off. And that happened 3 times because apparently I wouldn't be learning after the first time not to do that.
Yeah, good thing you learned.
I learned after the 3rd time, of course. Yes.
Hey, there we go. The topic of this.
Exactly. That's what I learned this week is that I still needed to tap initial holes in, just kind of like the size of the diameter of the screw, but not the threads, so that the threads would be like in contact, and it greatly decreased that frictional force.
Interesting. Cool. So you only had 2 final. I mean, it probably, I don't know, like projects seem stressful. I'm in senior design right now, and I'm just like, oh, are we going to get this thing done?
Well, that's exactly what happened. I mean, we had another...
and so how do you, what is the criteria for passing or failing that?
So he wants us to make a complete report about it, going over everything, kind of like the design and what you used and why you used it, and we also have to make calculations for certain components. Like we have got to calculate my bearings. I used 2 bearings for it. I calculate the bearings safety factor. I gotta calculate the safety factor of the shaft I used for the pendulum arm, and then I gotta calculate kind of the screws, their safety factor as well, and kind of like justify why I used each component that I did. And then I gotta submit a video with it showing that it works. And then obviously I've gotta leave it at the school in our specific room so that he has access to it so he can analyze it himself to see the design.
Oh my god.
That's scary.
Yeah,
given
for
Dr.
sure.
Kondaker, he's going to be ruthless for it. So it's going to be interesting.
I've heard he's pretty tough.
Oh, he's tough.
Yeah.
He's definitely one of the more tough professors, but you will learn if you apply yourself.
I see.
Definitely.
You gotta apply yourself.
You really gotta apply yourself, and you gotta show that you're applying yourself because he is big on that.
Hey, I'm applying myself
exactly,
over here.
With inflatable tube guys at a car dealership.
Yeah, that's hilarious.
Exactly. Yeah.
Jeez. Oh my goodness. So Connor, how was your week?
I am hopefully optimistic about my finals.
Yeah.
I choose to stay that way.
Which one do you think gave you the hardest time?
Genuinely, math, physics too.
Really?
Yeah.
Okay. I haven't had to take that.
I was mostly worried about digital signal processing.
Yeah.
Oh yeah, I've been jobber.
So I studied a long time for that.
Yes.
And I really should have split it up more evenly, studying between those 2 tests, because math, physics 2 came, and I was like, I know this material, I just can't remember the equations.
Yeah. You didn't. We weren't allowed a cheat sheet or anything.
We had an equation sheet.
Okay.
It was really more the manipulations.
Oh yeah, no.
Like what kind of exponent manipulation?
Fourier transforms and Laplace.
Fourier
Okay, those are fun.
Yeah, because isn't DSP kind of like an extension of signals and systems in a way? Kind of like control systems. Yeah, no, that's difficult.
Yeah, it's essentially signals systems. You're dealing with continuous waves, right?
Yeah.
And then in DSP, it's discrete samples, right? I mean, you can have a continuous discrete, but that's going to take a lot of computation, right? So you try to break it down into smaller pieces.
And then you can just use a mathematical model of a sine wave to
do different
complete
things.
Whatever output you're going to create.
Yeah. I mean, that was really for me my hardest final. Like, I had a take-home test in solid-state devices with Dr. Lamachani. That was pretty chill. I will be honest though, if he made it harder, like he easily could. Like having to take that test in person with just one page of notes, like most professors give, would have been super hard.
Oh, absolutely. Yeah.
Because in that class you get into like the quantum mechanics of like solid state devices and solid materials, and so you're having to apply the wave equation to lattices, and it's tough.
Exactly. Yeah.
I mean, it's quantum mechanics. Like, come on now.
It's hard to understand.
And then let's see here, control systems with Dr. Zhang. His classes are typically pretty chill. Like, it's like he wants you to sort of understand what the material is about, but doesn't expect you to like be an expert in it. Doesn't expect you to like get the like the specific answers to the questions, right?
He's more relaxed.
Yeah, he's like one of the more relaxed graders that I think I know. But that, man, like control systems is weird because it seems pretty chill, and then you're like trying to essentially manipulate these graphs, and if you don't know all the rules and things to do them, and like, you know, I was spending a lot more time on DSP than any other class, and along with that I was like trying to run a club and like do a podcast and do research and go to conferences.
A lot for control systems especially. Yeah, it's a lot of responsibility.
So yeah, but then DSP, man, it was the only class that I've just been like teetering back and forth through the whole semester.
On that trip to that conference around midterms, and you came back the day before and had to take the midterm. I was like, are you good?
Studied one day, got a 74.
That's really good. 74 in engineering is like 110 in anything else. It's just ridiculous how hard it is.
Yeah.
So one day of studying for 74, that's insane.
Yeah.
That's insane.
Yeah. So I'm hoping with this whole like essentially like week and a half of studying for that DSP final, I did all right, you know. So I think as long as I got a 70 or above, we'll be good.
Exactly.
Yeah. So I guess it's just like I never really thought of in signals and systems, right? Like I just got out of differential equations, and you get into actually like using these differential equations to essentially like look at different waves and how they behave, and I didn't really think about what actually we're doing. I just did the shut up and calculate thing, right? And that got me through signals and systems just fine. But DSP, I don't know, it just felt a little bit more abstract, because instead of this continuous thing, you're taking samples and then you're like having to, I don't know, it's just, I had to actually sit down and like really try and use my imagination and like really think thoroughly through like what exactly am I doing here, because I don't know, I felt like in signals and systems, Dr. Benjabar, like Ben Jabbar.
I heard you've been calling him Benjabar, and I think that's the funniest thing ever.
No, that's like my first. That's like my first go-to, because that's what I first started saying. Because I was told by somebody else like that was how you say his name.
I think someone trolled you.
Probably. And then I asked him, right, because he gave a talk in front of Physics Society. And it's so funny. I asked him, I was like, so how do you say your name? And he said, Ben Jabbar. And then I got up in front of everybody, and I'm pretty sure I said, Ben Jabbar.
Oh, no.
I was there. You did.
Yeah, and then I'm like speaking, but then conscious of like me saying the wrong name.
Absolutely,
I like started to sweat a little bit. I was like, oh no, what did I just do?
It's so hard to fix a first impression like that. It's so hard. Someone trolled you and it's still going in.
Well, and then it's like, it's one of those things that you've done it so many times.
Oh, like repetition,
Yeah, that it's just like stuck to you.
Absolutely.
And so to be able to like unstick it and put something else there.
Time.
Yeah, it's so weird. And that's just with a name. Think about all the other different ideas you have in your head that are just like totally wrong.
Yep.
And you're trying to fix them. But so in DSP, so in signals and systems, I felt like it was more like shut up and calculate. In DSP, I felt like he really wanted us to like conceptualize these things, and he forced us to do that, right? I think that's why some of the quizzes were really tough, because I'm like, I haven't really had time to like really think through these things and figure out what exactly we're doing. Like, I just give me the problem where I can just apply the definition to it, and do some math and a little bit of manipulation and get there to the answer. Instead, it was just like, you had to think through the problems. You had to conceptual, and you're like, I haven't done this.
That's something that I feel like most people in engineering nowadays, for like the students, I feel like that's a problem for us. Is we kind of just do the shut up and calculate method, and it works to an extent. It works, and for some professors, it works more than others. But when you have professors like Dr. Benjaber that know and they want you to learn, that didn't get me through signals very well. That method has been, especially since it's an electrical class, I'm a mechanical engineer, I'm probably not going to be using it that much, and so it just further justifies the shut up and calculate method.
Well, I mean, it's mechanical too. Like you use differential equations in there to look at mechanical systems. You don't do it much because the labs are mostly around electrical stuff, right? But there's definitely I remember a lab where we did look at mechanical differential equations.
Suspension system. Yeah. That one was a very long lab. But we looked at the automobile suspension system, and that was definitely mechanical focus, and that is definitely something that we would be dealing with regularly, depending on what field you go into, obviously. But I just thought it was interesting, his approach to teaching, because he doesn't let you just do the shut up and calculate thing. He really wants you to understand what's going on. And for me, something abstract like signals and systems doesn't come to me as intuitively as mechanical systems. So it was interesting, but that is one thing I definitely learned from being with Benjaber, is that it was kind of an awakening for me to really understand what's going on and not just plug and chug and not just try to just shut up and calculate. And I think that was a big thing I learned this semester too, was just trying to understand the concepts, trying to understand what is going on, why is it going on, just understanding everything the class is. I mean, you can say that, and that's something everyone says, but you don't really do it when you get stressed out. Everyone just shuts up and calculates.
Especially when you don't have time. Like,
exactly. My God, all these classes.
I gave myself way too much this semester. I have 15 hours, and I just listed all the different things just a second ago, and I didn't realize that, you only have so much time in the day, dude. Yep. I mean, I guess I had realized that. I always get myself into trouble by biting off too much, and every semester I've just bit off a little bit more, and then this semester was the breaking point, where it was just ugh. The last month I'm just my brain felt broken, and I was just okay, we just gotta trudge through this, we just gotta brute force this to death to get through it,
picking up pieces of your psyche and putting them back together before finals week.
Burnout is awful.
Oh, absolutely.
Hello, space travelers. Want to look sharp while bending space-time? We've got brand new Physics Society t-shirts. The clean graphic tee is just $20, and if you want to drop some Einstein-level wisdom on the back with this quote, "I have no special talents, I am only passionately curious," that one's only $25. Rep your curiosity, rep the cosmos, and support the Physics Society. Grab yours today before entropy takes over.
Burned out earlier this semester than I usually do, and this was my easier semester. Next semester I got heat transfer with Dr. Hassan.
I always find the winter semesters a lot of people burn out quicker than in the spring.
It's weird. I don't know why.
I guess it's seasonal
something
depression.
In the air. Something, I got no idea.
I'm telling you, it's the warmth, guys. I feel like we have more energy when it's warm.
I think it's the shorter day lengths, and it gets so much darker.
When it gets
so
dark
much
at
quickly.
5:30, and you're just depressed for no reason because there's no lights, and you're just what's happening?
Maybe, I don't know, maybe you could talk to this. I'm not really sure how versed you are on the mitochondria, but apparently, and we talked a little bit about this last week, but your mitochondria mitochondria need the signal from your brain that there's light outside so that they can start creating energy.
Interesting, yeah. And that makes sense because a lot of people in Alaska actually moved to the States during the winter because of light depression. Like a few weeks ago was like the last time the sun is going to be up above the horizon until like March or April for Alaska. The sun just never gets above the horizon. And during the summer, the sun never sets. It's always sunny outside, no matter what time of day it is. 3 a.m., I was on a cruise, 3 a.m. Didn't realize it was that late at night because the sun was still out. Sun was never going to set.
Oh my
I can't use the sun as a tell for time.
There's a reason why there's a lot of like horror movies around Alaska.
And that's why a lot of people come down here. It's because they get so depressed because, like you said, there's a biological reason for why we really need to have light, and light is good for us with vitamins, obviously, but it just helps us, be more lively and be less depressed.
That's one of the reasons why during the winter I turn off my blue light filter on my phone. Because I want the blue light in my eyes.
Yeah,
I'm like, I need to be awake.
Well, so like, I wonder what kind of blue light that is, because apparently like LED blue light is actually bad for your mitochondria, which can actually depress their energy making activity.
Is it a specific wavelength, you think?
I think so. So I heard this on the Huberman podcast, Huberman podcast, and they were talking about how LEDs are affecting people's mitochondria, and it's sort of scary though because it's like LEDs are everywhere.
Is that going to change though? Because previously blue light from LEDs was a combination of green and red and yellow. But now we've created an actual LED that'll just eject the blue light.
Yeah, I don't know. I would like to definitely look more into that. Like, what's the specifics of that? Like, what is it? Like the blue LEDs what we're talking about, or is it just the blue wavelength that like can get you?
I wonder if it's specifically the wavelength. That's hard to change because if you know the history of the blue LED, it took a long time and just the man that made it went through so much just trying to make it. And just with how difficult it was to create that one, I feel like it's going to be really difficult to create something like, if that is something that's like a big deal later on down the line, to create a slightly tweaked version of that with a different material that emits that blue light at a slightly different frequency. I wonder how difficult that's going to be.
Yeah. I mean, I used to think that it was just like you throw like a blue cap.
That's why I thought it was paint.
White light.
I thought it was paint. Yeah. You just paint it blue and just put a white light underneath. I didn't realize it was actually emitting that color.
Quantum mechanics, man.
It's crazy.
Yeah.
I always thought it was like a polarized lens that filters out the other wavelengths and just lets that one through.
They should have tried that. Just blue paint, guys. That would save you like $20 trillion or however much it cost.
Yeah. But I mean, apparently it's more efficient though whenever you're just, using quantum mechanics to your advantage.
Who would have guessed?
Yeah. That guy didn't guess. He worked hard at it.
Oh no, he worked. Yeah. I mean, part of it was just guessing different materials, but a lot of it was just like troubleshooting and trial and error over like many years. And the company was like trying to fire him and trying to defund him, and he was just so resilient. And I'm glad he did it, because it has exploded into everything you see now.
Well, that's what's. Go ahead.
And I was going to say, it's saying that he guessed it is so reductive, because like there was a lot of thought.
Yeah.
Oh, absolutely.
It was definitely trial and error.
And he built his own machine to test the specimen stuff out. He reverse engineered one and then built his own and made improvements upon it. It was insane what he did.
And I think some of those trials he actually had to manufacture the material himself.
Oh yeah.
Crazy. Yeah, and then like, what I've learned through solid state mechanics and like quantum taking what was it, modern physics, I think is where we learned that at, where certain materials give off certain colors because of the frequency at which their lattices are vibrating. It's like, wait, what? Yeah, and so that's why like certain rocks and jewels or whatever have certain colors because of like the way that they're vibrating, and it's like, okay, yeah. And apparently there's like telescopes that you can use to actually look at that vibration, which is kind of crazy.
Interesting. I even know I would love to see that in person. That'd be so cool.
Yeah, yeah. I mean, just think of like the engineering to like try to figure that out.
Oh man.
Right? Like, you know, I really think that that's what I would love to get into is like building these like probing machines, right? But then like probing like literally like the tiniest things, right? Like how do what is it? The electron microscope, or I think that's what it is, where they actually, you can see the atoms.
Yes.
Mm-hmm.
Each individual atoms. And I'm just like, what? Those things are so tiny. How do... And then the way that they go about it is like, I think it's like reflecting lasers or something.
They bombard them with electrons. I think it's just like an electron gun. They just bombard with electrons, and then you get to see. Like you can only zoom in obviously so far, and obviously you can't see the electrons. You can't really see as much of the nucleus, but you can see the individual atoms themselves. And there is a very Veritasium video on it, and it's super cool. Just going into like kind of how they made that machine and like how little we can get. I think the video is like how small can we see or something like that.
Yeah.
Where it's like you just keep zooming in. What happens when you keep zooming in? It's super cool.
Yeah, I mean, I imagine, you know, the millions or possibly billions of dollars that they spent on trying to figure that out.
Yeah.
Like, because I'm pretty sure I watched a documentary on YouTube about like the history of that telescope, and it took people so long, and people were just like, "You guys are ridiculous. Why are you even trying?" And it's like, that's not the way we should think of this. Like, we should just like
Do it.
Yeah, exactly. But I wonder, like, what the application of that is. Like, okay, we get to see the atom here. Like,
so there actually
like,
is
the defects,
an
maybe?
application. Yeah, it's mainly defects. So I actually watched a video on like the physics of bells, like the bell tower, like the Liberty Bell, and they need to make them a certain way, or else if there's enough defects in a certain like manner, then the bell will actually like split and it will crack and fracture, and that's what you see with the Liberty Bell. So certain bell manufacturers actually have sent their specific test samples of different like pieces of what they're trying to create out to make sure that it's consistent in the manner that they see fit, so that when they make a bell, they know it's not going to actually fracture off. And they're actually looking at the arrangement of the atoms in a certain way to make sure that, okay, this is exactly what we need, and we know based on history that this isn't going to break. This is going to work just fine. And that's what they're looking at. So there is, weirdly enough, a real-world scenario where you actually need an electron microscope.
yeah, I mean, so fascinating.
That actually reminds me, in history class back in high school, I learned that during the Revolutionary War, because bells were so finely made and sturdy, that the colonial army actually started stealing them to hammer them and forge them into cannons.
Well, yeah, they did that, and they also did that with like they made rounds out of it too, like just projectiles and stuff like that. But yeah, making them into cannons, I guess that checks out.
Something dark there is like apparently they were taking like soldiers' golden teeth and like melting those down and using them as bullets as well.
Yeah, that's sinister.
Yeah, dude. Well, I mean, you got to do what you got to do if you're running out of bullets, man, and you're trying to fight
Start
the red
using
coats
teeth,
off.
you know. Consult the tooth fairy for your munitions. Yeah.
Oh my gosh. But so speaking of bells, like one of the things that really like flipped the switch for me this semester is thinking about the bell and thinking about the frequencies that they put off whenever you hit them, right? And also thinking about the energy of that. And so it's really weird because the more energy a signal has, right, the longer it goes on for, right? And whenever you have an infinite signal, so a thing that has infinite energy, you're able to pick out exactly what frequencies are in that signal. So whenever you just barely tap the bell, it's like an impulse, right? And so you're not really able to tell exactly what frequencies are in that, and because it has like close to zero energy, so the more energy you have, the more boom you give it, the more you're able to pull out more information
Because it's amplified.
Yeah.
amplified. But then because it, think about like a I want to think of this. So I don't know, to me it just makes intuitive sense that the longer you're able to look at something, the more information you can pull from it, right? And if you have an infinite wave, something that goes on forever, you can sit there and study it all day.
Yep.
Right?
That's why in astronomy there is a proposal to actually create a satellite that will use the Earth's own magnetic field and gravitational well as its lens.
Yeah.
So it'll sit on one side of the Earth, and then it'll gather light as it goes around and bends to then use to calculate the image on the opposite end of the Earth.
Oh, that's so cool.
Yeah, I think Zuckerberg is apparently trying to spend billions on this. Yeah, but it's using the sun, right? I thought they were using the sun as a microscope. I thought that's what they were doing. And then it's like
I think that's for a later version, but because it would create a much more powerful lens.
Let's look it up.
Let's look it up. Oh, God, we have to hear you. I want to see.
I am very much a layman when it comes.
Man, billionaires
terms
really love
of
investing in
astronomy.
space. This is interesting.
Boom! It's like the first thing that comes up. Using the sun as a telescope. Let's check this diagram out.
That's so cool.
Okay, so exostar and planet, sun. Where's the Earth at? Okay, the Earth's not even in this. And I wish I could tell you guys that I could read these Feynman diagrams over here.
Well, that's saying 550 AU, so that's out, I want to say near the Oort cloud.
Wow.
That's
Yeah,
beyond the
that's
solar
probably
system.
can't see the Earth because we're 550
Yeah.
astronomical units away.
Yeah, type in using the Earth as a telescope.
Okay.
Yeah, that's what I'm talking about.
Okay.
There we go.
That's a beautiful picture right there. Oh my gosh. I'll accept your cookies. Cookies do sound good, dude.
They do sound great, yeah.
I like starve myself during the week, and then like on the weekend I'm just like, give me sugar.
Exactly. It's exactly what I do. It's my cheat day.
Yeah.
And so I like load up on Nestle or something. Yeah.
Yeah. Kind of something. Yeah, that's pretty crazy. I mean, yeah, let's do it. Let's build it. You guys want to build it?
Let's build it.
Because one of the difficulties with telescopes is you have to gather light. And so the larger the lens, the more light you can gather.
Yeah.
And so that's why astronomers, they have the radio telescopes where it's the large rays of satellite dishes pointing off into space. But they also have a plan to create an array of these radio telescopes on like one end of the continent, another on the opposite end, and then they'll sync the two emissions. Because radio waves, when you're trying to get as small as possible, the wavelengths get super large, to where it's going to be like miles and miles between the peaks. And so they have to be far enough away that you can actually detect even like just a curve of a peak, because if you can detect that, you can calculate the full wavelength.
Yeah. Yeah.
And so using the Earth as a telescope is just like as large a lens as we can find.
Yeah.
Pretty much.
That's crazy. I mean, because to me, I think of a lens and I think of something that's like you can see through, right?
Exactly.
That's
You can
like,
think of it like a convex or a concave lens, piece of glass or plastic.
using the moon. I mean, the Earth as one, though. I mean, I guess it makes sense.
Yeah, it's
Is it still
not
curving
done yet.
light? Yeah.
Yeah.
Very conceptual, but
Interesting.
I stumbled upon this one late night.
Yeah. All right, Connor,
was-
figure it out and come back
We'll build it
on
in our
another day and
garage,
tell us
yeah.
all about it. Oh man, so what was I gonna say? I don't know. I don't know. Just so, have you guys seen where they're like gonna try to put a data center up in space?
I have not heard anything about that.
Yeah, and
That would be very
Rings
difficult.
a bell? Oh, okay, sorry.
Because if it's like an AI data center, so much waste
power anyway. Yeah.
Well, waste heat. That's the thing you have to care about in space. Like you have to radiate that away somehow.
Mm-hmm.
So otherwise it's just going to melt itself.
Waste heat. Okay, so you're saying the heat that it's putting off, right?
Can't use fans.
But isn't space like pretty cold?
It's not cold. It's basically like as close to a true vacuum as we can find.
Okay, so there's no like medium for
heat transfer, yeah. Which is why we have to have.
How do we get heat from the sun then?
IR.
Radiation. The sun radiates the heat in photons and little bitty charged particles that it sends out into the void.
That's the only way to get heat from in space, and that transfer heat is through radiation.
Yeah, and again, space is not like a true vacuum. There are small particles moving around.
Is the data center not radiating the heat from?
No. Space has like an amazing insulator, and so if you don't radiate that away, that data center is just going to cook itself.
Interesting. Yeah, from what I've heard, it's just like the perfect cooling system. From what the people, Elon Musk is saying this, like, and then also to power it, they're just going to use like solar panels, right? And apparently, you get like 60% more efficiency from the sun when you're outside of Earth's atmosphere.
Yes. But there's a lot of caveats to that.
I was gonna say there's a lot.
Okay, I'll have to look more into it because, I mean, to me it makes sense. I don't know, but because I don't know a lot about heat transfer though, so.
So you could use liquid ammonium. That's what the ISS does, I believe, and then it just kind of uses the liquid ammonium to absorb the heat, and then just kind of blasts that heated up ammonium out. But if it's like a large data center, that's like if you ever looked at like the plans for like the Tesla city down in Texas, where it's like a huge data center and it's going to have like live-in employees or whatever. It's like a company town.
Yeah.
That's going to be so much larger than what the ISS is. So I just can't see that happening with the current state of space travel.
Yeah, I don't know, but you know, we're engineers. We should be thinking about it, right?
Oh, absolutely, yeah.
So, I mean, I don't know. To me, I'm just like, if Elon said we can do it, I think Andre Karpathy, he's thinking we can do it. I'm like, let's go. I mean, those are the people who seem to be thinking about that sort of thing quite a bit. So, it's like, I'll just regurgitate what they say.
Do you think there's any data on how they're cooling it off yet? Do they have anything online?
Let's look it up. I'm gonna pull up ChatGPT for this. How about that? Let's see here.
Because now I'm invested. It's like all I can think of is radiation for heat transfer, and that's not really.
What?
Just be aware that we are asking AI to tell us.
Yeah, so it's like, you can do it.
I trust Wikipedia way more.
Okay, all right. Then I'll ask Google, I guess.
Well, Google uses AI, so like scroll past the little AI word that it'll
you want me to go to straight Wikipedia and ask the question? Hey, can we do AI space? Like, what?
Well, Wikipedia is monitored and.
Okay, fuck it. I'm gonna ask Gemini. I don't care. Yes, I'm.
This is our middle ground.
Oh my god, it's taking forever. Okay. What should I ask it? Does it make sense to put a large data center in space? My main question is how to deal with all that heat, dog. That heat it will be putting off.
Did you put dog in there?
Dog. They say not to talk to it like a human, but I like to talk to it like a human.
Oh yeah.
My sister and mother says please and thank you.
Yeah, and do you see where Sam Altman came out and said like, hey, you guys are wasting a lot of compute hours on saying please and thank you to ChatGPT? I mean, what a nerd thing to say. Let's see here. That's a fascinating question. A major, yeah, I never read like the first paragraph anymore because it's just like saying, "What a great question." A major obstacle. It's like I know it's a great question. That's why I'm asking, dude.
Yeah.
A major obstacle is the very thing that makes space seem like a good place for cooling. No convection or conduction on Earth. Air, liquid helps carry heat away. In the vacuum of space, you can't use these methods to transfer, like what you guys were talking about. Radiation is the only way. Heat can only be released into space via thermal radiation. The larger the data center, the proportionally larger and more complex the radiating surface needs to be, which adds massive weight and logistical complexity to the launch. A large data center waste heat would require radiators spanning acres to be effective.
Oh
Acres.
my gosh.
And how do you get an acre out in space?
A really big trebuchet.
Oh, okay.
Well, it's easier
Wow,
now
what are these
'cause-
guys talking about then? I mean, maybe they're just thinking like 100 years in the future or something.
I guess so. Yeah, this is definitely something like.
Yeah, I always take what like
Yeah.
the quote unquote tech bros
Yeah.
say with a massive scoop of
Dude,
salt.
I'm a tech bro.
They're just
so-
trying to think of it, like if we can do it, not how we're gonna do it.
Yeah.
They're very much more dreamers than they
Oh,
are
absolutely.
doers.
Yeah. I'm in that same camp, dog. I love to dream.
They just have the money to put like
Yeah. Yeah.
paychecks that they're.
Yeah.
And you tell the lead engineer and he has an aneurysm, like, oh, this is gonna be fun.
Yeah, currently the consensus is no, not for general purpose computing. The immense cost and technical hurdle. Okay, well, we figured it out. Thank you, Gemini. Gemini's not a dreamer, apparently.
Gemini's not a dreamer, not a tech bro.
We need an AI dreamer in
We need an
here.
AI dreamer.
Yeah, we need a much more robust space economy before we can even think of doing that.
Interesting. Well, it's good to know,
Yeah.
right? I mean, I'm sure a lot of people out there are just like doing exactly what I did. Like, hey, Elon Musk said this is gotta be true, right?
Yeah.
We're gonna get it tomorrow.
Yeah, like I like to dream of solar cells and even electric cells and
Yeah.
like future space travel between the stars and whether you have to have generational shifts or if you can actually go into stasis. But like,
Yeah.
I'm not saying we should need to do that in the next 20 years.
Yeah.
I'm not saying we can do it in the next 20 years.
Well, we have the science. We know what we need to do. We just don't have the material science to do it.
Let's go material science.
Like realistically, we could just with basic mirrors, we could do what's called star lifting and basically mine the sun.
Let's do it.
We just need the materials and the infrastructure to accomplish that. Like
Yeah.
we know, like even with today's technology, we can do so much. It's just not economic to do it, and that's
Absolutely.
what we
What a
don't.
Debbie Downer. Alex, how was your? I'm joking. I'm messing with
And I
you.
think I told someone this the other day, but that's why in the 80s, where you had like all these really cool concepts for like solar farms in space,
Yeah.
because we had an oil shortage at the time, and then new fields were found, and then we had like an oil glut, and overnight those projects dried up.
Yeah. Interesting.
And so that's why one of the reasons why it's come back into like the modern vocabulary, modern people's mind, is because again, we have much more concise data on climate change. So like even the deniers are like, this might be a problem.
Yeah.
But also like we now have greater infrastructure for these alternative forms of energy, whether it's wind or solar, and
Sort of.
we have a more robust space economy now with reusable rockets at this point. And even though those aren't like where we need to be, we need to like push that further to where instead of I think it's what $300 a kilogram with those reusable rockets to get into space, we need to get that down to like $100 or $45 a kilogram.
Yeah. Well, I mean, I think that's what is exciting about so many people trying to go to space right now is that hopefully the more people do it, the cheaper it gets, right?
Yeah.
And the more people doing it, the more research that is happening that in turn, hopefully, makes it cheaper. So apparently a lot of it is, again, material science, right? Especially in trying to reuse the whole spaceship. The whole rocket, right? Because apparently you have to change out the outer shell every time, and so apparently Elon is trying to figure out what is a ceramic that you can use that you can actually reuse without having to do anything to it again or having to replace it. Which, yeah, if you think about it, right? Like, you're going through the atmosphere and it's literally catching on fire.
Oh, absolutely. It's like so hot up in the mesosphere once you get to that layer.
Yeah, it's like one of the most extreme environments you can think of, and that's what you're having to put this material through. And it's like, okay, well, how do we figure out a material that can be reused after that? And it's like, good luck, I don't know.
That's why you have other initiatives like, what was it, like Spin Launch, where it's literally just a giant centrifuge that's trying to launch stuff, like missiles into space.
Oh,
And then they just fall down in like these tucks and draws that they can go recover.
Yeah, but like, and I've heard that that's promising, but like at the same
I've also
time,
heard like they can't guide it because the centrifuge causes too much angular momentum to where even if it launches straight, it'll like kind of tumble in the atmosphere.
yeah. Oh my gosh.
Oh, I'm just thinking about that. That's just like the most redneck thing I've ever heard. When we make it spin fast enough, when we let go at the right time, we'll get her up there.
I mean,
Sorry to our redneck friends.
I mean, yeah.
No.
Macedonian sling regiments in ancient Greece, they were deadly. Hell, the Romans used slings, and they.
Oh yeah, no, they're very effective.
Yeah,
It's just funny to think about.
Yeah, and that's a huge issue in it, right? Is how do we not expend, like, there's like hundreds of gallons that get expended by just trying to shoot yourself out of the atmosphere.
The tyranny of the rocket equation.
Yeah, and you still have to use like these super like processed gases, right? That you have to like get in a certain form, and that costs, I'm sure, billions of dollars, and yeah, it's pretty insane, dude. So I want to ask you guys, what is there something like in the break that you're like looking forward to, that you're just like, oh yes, finally I can go do this thing? I know Connor was talking about like catching up on podcasts or something like that, or is there like a trip that you're going on? Like what is going to be like? Do you have something that you're just like, oh, I can't wait to do this?
I'm not really planning any trips this time, but what I was planning on doing is the new Battlefield came out.
Okay.
And I purposefully do not play games during the semester, specifically because...
Hear that, ladies? Alex don't play games.
I don't play games, girls. Hit me up. Just kidding. I have a girlfriend now, so don't do that.
Oh, yeah, that's
right. I love playing games, and it will get in the way of my semester. So I deliberately, during the semester, avoid playing games just so that I can focus on school. But as soon as the semester's over,
yeah.
Oh,
so
baby.
then how do you switch your brain from like being able to play video games and then like semester starts and you're like, because I know
do it.
Video games to me are addicting.
Oh,
dude.
absolutely. During the break, that's what I do.
I don't touch them. I'm just like, I know I'll be addicted.
I have to just turn my brain off from that. I have to just say, all right, we're done for like 3 months, and then I get back into it. And it's really hard if I'm like playing a really nice single player game and I really get to a good part of the story. I'm just like, all right, I can't think about the cliffhanger right now.
Yeah.
I have to just stop.
Well,
and
it's
I just
good
wait.
that you have that discipline.
It took years. It took a while. I made a lot of mistakes to get there.
Yeah.
I enjoy story-driven games.
Oh, absolutely.
And this last month and a half, I got back into Mass Effect.
Okay.
Because I have the definitive edition, where it's got all 3 games plus the DLCs of each.
DLCs, I don't know. Throwing out acronyms for non-video gamers. I'm like, what is going on?
Downloadable content.
Okay.
It's like add-ons.
I thought it was some kind of magic you were trying to conjure up here for a second.
Oh, yeah, no.
But I have to stop myself.
Oh, absolutely. Yeah.
So at the end of the night, once it's like 9:30, I'm like, I'm done with work. I can't do anything.
Yeah.
And then I go to bed, but then in the back of my mind, the Xbox like, hey.
Yeah.
So like I'll get 9:30 to 12. I'll be playing a game.
Oh, absolutely.
And then like once 12 hits, my body's just like, go to bed.
Yeah.
Once I hear the birds chirping and I see the sun up over the horizon, I'm like, I really screwed the pooch on this one.
So like in the last month and a half, I've done game 1, I've done game 2, and I'm basically done with game 3. And I'm just like, I want to go again.
So what's your guys' console that you use?
Xbox X, I think.
The Series X?
Yeah, I think so.
Yeah,
Is that the newest one, or?
Series X is the newest one.
Oh,
yeah,
okay.
it's able to.
Okay,
It
let's
has a really
go.
nice APU, and it's actually. I love it. I don't have one yet. I'm gonna get one at some point.
So you're an Xbox guy too?
I've always had Xbox. I've had
Okay.
like some PlayStations in the past, but I've always just been Xbox because that's what all my friends have.
I see.
But they have a really nice APU in this one now, and so APU is so it's an integration of a CPU for just like your basic processor in a computer, and then your graphics processor, GPU. It's integrated into one chip.
Oh.
That's how PlayStation and Xbox make their stuff.
Okay.
They have a really nice one now that you're playing 4K 120. 4K 120 hertz.
So
And-
4,100? 4,120? Is that what you're saying?
No. Like
4K
4K resolution. I always forget to explain it. So yeah, 4K resolution is the highest mainstream resolution right now. That's practical. We're not doing 8K yet.
Is it
but,
100 hertz? Is that the?
120 hertz is
Oh,
the
okay.
refresh rate, how fast the refresh rate happens on the screen, so it's smoother gameplay. But going from 60 to 120 hertz is a big step in like how big of a processor you need to be able to do that. And so you're doing 4K 120 hertz. Most like graphics cards you're buying for a computer, in order to do that at like high settings,
You
is
need
like
a 9.9.
like $1,000 easy, and they're selling it at like $500 for just the entire console itself. So it's really insane how that price point has gone down so much. I built my own computer, and I still think I should have just gotten Xbox Series.
Did you hear where Steam's coming out with like their own console?
Yeah, Steam has their own console
But they're
coming out.
pricing it at like an expensive laptop, even though
I don't understand why.
even though you can buy a better gaming PC with superior specs for less.
Well, it's probably because it's their first one, right? It's probably a lot
I think it's
of
because all the
research
R&D,
development.
all the R&D costs are going into it. But
I know,
still,
but it's basically a console, but they're pricing it as a computer instead of pricing it at a console.
I've got a buddy at
Yeah.
Steam. I'll call him and let him know that you guys are pissed.
Yeah, please take it up to the top. This is getting ridiculous now. It used to be that like computers, it made sense because you can change all the components and you can repair stuff. That right to repair is there, and that still can save you money over time.
Repair stuff?
Like,
what do you say?
Like it's called the right to repair. It allows you,
Okay.
like, they used to have those cell phones where you could go in and like change your own battery. Now you got like
Yeah, you can't do that with consoles.
adhesive off.
I
With
see.
consoles, you really can't do that. They kind of make it. They really lock it down with software. You gotta be like a software engineer to go in and like change stuff if you want to, and really know what you're doing. You can't really change anything.
Yeah, I've got an old PS4 that I've been wanting to just mess with.
It's
and see
fun to
what I
mess
can
with.
do. Yeah.
There are people out there that on source code on GitHub that can do it, but it's just really difficult.
And PS4s remind me of the story. Was it MIT or was it Harvard? One of the research institutions on the East Coast. When I was in high school, they needed a supercomputer, but they didn't have the budget for one. So they just went out and bought like 800 PS4s and hooked all their processors together for like a third of the price of a supercomputer with
probably
the
genius.
same
That sounds
processing
genius.
When was
power.
this?
I
gotta look it up.
want to say 2014.
Oh, that's so funny.
Oh, no, batteries running
That's
low.
like
I gotta look this
before,
up.
like the Bitcoin, whole insurgency,
There we go.
where people were buying like during COVID, graphics cards were exploding in price. Like a normal like graphics card that cost $300 was being sold for $900.
School.
Okay, so it wasn't PS4s, it was PS3s. My bad.
I figured because
And it was the U.S. Air Force.
the U.S. Air Force
It
did
was
that.
the U.S. Air Force.
Oh, okay.
Oh my
Yes,
god.
Air Force.
Okay, but
Yeah,
they have
there's
like
the picture of
basically
it.
unlimited money. Why are they using PS3s?
College researcher makes supercomputer from 420 PS3s.
Oh my gosh.
What?
Wow.
When was this?
Jerry
Hack a day. look at this guy. He looks like he could do that.
He looks like PS3.
Look at this huge, like, power.
I wonder how much power is going to that. How many kilowatts?
Funding for Science has run dry for many researchers. Gaurav has built a supercomputer from 200 PlayStation 3 consoles housed and chilled inside an old refrigerated shipping trailer. Wow. His mission at UMass Dartmouth from the National Science Foundation is simulating black hole collisions with an eye on learning something about gravitational waves. Wow, I bet he learned a little bit something about some computer engineering and software engineering
that
too.
looks how they're locked down. That's interesting.
Wow. Okay, let's look at some more. This is a fascinating.
I want to see the cooling rack.
Yeah, let's see here if we can get. Oh, which one? This one?
Yeah.
They had to like engineer their own cooling rack. I feel like for that.
Yeah, something. What is this one? Composed of many PS3s.
Wait, those are just like normal racks.
2010, yeah.
They're just like shelves you can buy at Lowe's.
Yeah, dude.
What?
I mean, I doubt they make racks for
I think they just
PS3 processors.
No. They just designed this themselves with just things they could buy at like Target, which is
Wow.
insane.
That is insane, dude.
And this is the Department of Defense. They got billions behind them, and they're like, you know what? We're gonna get some PS3s from.
But if you think about it, right, whenever you start a project, right, I know this because my girlfriend's a project manager, right, is you only have so much money. And so you have to figure out what you can do with that money. And they were probably like, well, PS3 is the way to go.
Brilliant.
Yeah,
honestly.
apparently, from what I'm seeing, it took them about $2 million to do this, which is a tenth of the cost at the time.
So cheap.
Oh, okay. So cheap. You must have millions of dollars.
Oh yeah, I'm rolling. Yeah,
Well,
I'm
a
rolling.
supercomputer, it's like tens of millions.
Oh, absolutely. Like our buddy computer. We have like Tinker had $1 billion supercomputer project. They scrapped and gave us all the parts. And so over the break and all into the next summer, we're just gonna be installing all those parts in the buddy, our UCO supercomputer. And it's still not even with that stuff we're adding, it's not going to be nearly as powerful as someone like OU, Oral Roberts. We're still behind on that.
I run simulations on OU and OSU supercomputers. Oscar and Pete, shout out Oscar and Pete. Like, man, it's kind of crazy because you can go in there and you see like all the GPUs they have, like H100s, A100s, and like I start salivating. I'm just like, oh, I can't wait to run simulations.
Yeah, we toured a data center not too long ago at OU. We went to go see their data center, and it's so cool just seeing how their setup is like so much better than ours. And we're using like graphics units from like. And like co-processors from like 2010.
Yeah, and the guy who does the tour over there is awesome.
Oh, absolutely.
He gave a talk. I forget his name. Let's see here. It's probably gonna take me forever to find it. No, probably not. Let's see here. Oscar. Dun, 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 dun. I get these alerts. What's his name? Anyways, so the guy over there that gives the tours, he's so great. He's given a talk here at UCO not too long ago at the ASME conference, and so he's like, he gave a talk on parallel computing.
Interesting.
And apparently, there's the Moore's law, right?
Yeah.
And so if you look at Moore's law, right, and if you only focus on the amount of transistors that you can get on a single chip, it's starting to sort of peak, right, and plateau. But what he tells people to look at is also what parallel computing has done to that. And if you look at it, how much parallel computing has sped up computation, we're just still climbing, and apparently there's still a lot of new things that could easily make it even faster. So yeah, I mean, it's interesting because like running on a supercomputer is not as complicated as you would think. It's sort of like VS Code, but with like an extra level of complexity. So I encourage anyone, like, go get a Oscar or a Pete sign-in because they're really easy to get. Well, I think you have to be doing research, but essentially I just said, hey, this is what we're doing for my research, and they were like, okay, here you go. I'm like, oh, like a kid in a candy store. I'm like, let's go.
It's just so much better that way.
And there's like some rules and things like that. Like you can't just go running things on like the main node or whatever.
Yeah, I can't go Bitcoin mining.
Yeah,
I think of the hash rate on that bad boy.
That reminded me of this post. It was from NASA talking about their internet speed, where they can do 90 gigabyte downloads in a second.
Wow.
And the first comment was me working at NASA, playing CS:GO, deleting it, and re-downloading it as my manager comes to check on my work.
Big brain.
Oh my gosh. Do you guys remember the first time that you downloaded VS Code or like some coding IDE on like your laptop or something?
Yes. I think my first coding was RStudio for Python.
Okay, let's go.
I liked
It's more
the
of a
pretty
data.
colors.
What is it? It's like a data science sort of.
Yeah, it's like it mimics like a computer terminal, where it's like you're pulling up your own computer's terminal to access its like core codes. It mimics that kind of setup.
Yeah, but I think there's like a bunch of. It's like built for data science.
It is.
Which there's like so many different languages out there. It's like I always am like learning about new ones. I mean, because I'm a computer engineer, it's good to stay informed.
It's good to
right?
stay informed, yeah. Might help.
But there's apparently this one. I forget exactly what it's called, but it like uses like rock band names for different things. I forget.
Interesting.
I gotta pull this up because it's so
That
hilarious.
sounds like so like Metallica and like what do you got there?
Rock band coding language. Let's see what it pulls up. Let's go all here. There isn't. Get the hell out of here. Yes, there is. Oh, Sonic Pi, including Sonic Pi, which lets you live code music per performance. Yeah, no, there's definitely that, which is kind of cool. Real-time synthesis, quirky rockstar language where code looks like 80s power. Plus, Scratch for building simple and band games. Huh. Rockstar language. Yeah, here we go.
It's just called that.
Yeah. It's a computer language based on the lyrics in 1980s hard rock and power ballads.
So interesting.
I didn't know codes could be like this.
Yeah, so I mean, essentially, it's just like you're building a language, or you're building functions to do certain things, and you can. I wouldn't say you can call these functions anything, but there's definitely you can be creative with it, right?
Looks like you can really call them anything.
Yeah.
We can really make code out of whatever we want to. You can make code out of like the 2013 Nissan Altima Owner's Manual if you want, I guess.
Yeah, I mean, there's a lot of like esoteric like coding languages out there. You know, I mean, of course, there's like the big hitters like Python and C++ and Java.
All of which I've used previously.
Yeah.
I'm so bad at coding, but I have to code a lot.
I mean, I think it's a great tool, right? Like, it's
Coding is great, and it's becoming like the most universal thing. Now ME's got to code, electrical's got to code, even biology people have to code now. Our studio is so big in the department.
It's one of those facets that just reaches out and is like, okay, I'm going to be here now, and you cannot get rid of me.
Yeah.
Which we could sometimes because it's not easy.
Yeah.
It's one of the things it's like learning a new language, right? You're learning a new skill. You just gotta spend time with it, right?
Yeah. I did coding in high school, and I was like, I don't want to do this for my life. I'll be an engineer instead. And then I go to engineering school, and they're like, you have to code a lot. And it's like, why would I do this if I'm not a computer science major?
You know, I think it's interesting because there's a lot of people who talk about that, like, you know, there's a famous Feynman quote, like, if you can't build it, you don't understand it, or something along those lines. And coding is one of those things that, like, you can go and try to build it in code, like, whatever it is, like, maybe something in signals and systems or DSP or whatever, even in, like, I'm sure really you could almost build anything in code, right? Some sort of simulation of some model that you're looking at in class.
Look at the people who are in Minecraft building
Supercomputers.
inside Minecraft building computers
With the
that
redstone.
can actually like
That's
dial
insane,
out, order pizzas, actually surf the web.
Okay, I didn't know about that. Because when I was like younger, we were looking at videos on like them making calculators in Minecraft.
They have made actual telephones inside Minecraft. They have made.
Yeah, this is like those analog computers from back in the day with the vacuum tubes.
Exactly.
Is the sound not on?
And that's exactly how they work. That's how it looks like how they work too. Interesting. Huh.
Dude has built this huge supercomputer, and apparently it actually works.
Yeah. How do you have time for that?
All simulated
my
inside
gosh.
Minecraft. It is wild.
is insane, dude.
I could watch this for hours.
Dude, it's crazy. Yeah.
Oh my gosh, that one on the right. It
They've
looks
made
like
entire game consoles to play Doom.
What?
Inside Minecraft.
It almost looks like the Saturn V.
There's like the one joke in like all the fields. Can you play Doom on it?
Oh yeah, and I guess you can.
They've played Doom on. We talked about electron microscopes earlier. They've programmed one to play Doom on.
Dude, this is insane. I like, and that is what, like, I try not to let it, get to me, but there are some people out there that just like are doing some like way interesting more things than I am. Like this.
That one's called Chungus 2.
But this one?
Yeah, and it looks like the Saturn V rocket module.
You see, back in 2020, most people were busy building fully functioning walking houses or update suppressors that
Walking houses?
Yeah, they're called redstone engineers.
Oh my god.
by just following simple tutorials. But in September of 2022, everything changed when a YouTuber named Sammy Uri came up with the most insane Minecraft idea ever. Let's take a look at the current biggest redstone invention. Before this player even started to build the redstone, he recruited 2 of the best redstoners and coders to help
Oh
him
my
build an entire computer out of redstone with 8 kilobytes of redstone.
What's redstone?
It's Minecraft's version of copper. It's like a conductive
It's basically
material.
electricity in a way.
Yeah.
You can have like turn on, turn off, and they have logic gates built in, so you can literally make stuff like this. You can make anything.
Allowed the team to finally play Minecraft.
It's crazy.
If you think about
They built a computer to play Minecraft inside Minecraft.
what, so meta. Oh my
It's
god.
insanely meta.
That's like meta. That's like meta squared, dude. That's crazy.
Like, imagine just being like the processor. I gotta process the game that's processing within the game. That's so
That's
confusing.
exactly what I was thinking of. I was like, so where does this
Simulation
game
inside
live
a
on?
Where is it exactly?
It reminded me of that Futurama episode
Oh, which one?
where they find out they're inside a simulation, so they
Okay.
build a simulation to figure out what type
This
of
is so
simulation they're
confusing.
I
inside.
guess I haven't seen that one. Huh. Yeah, I love Futurama. Apparently they have a new season now, right?
I think so.
Yeah. Yeah, I love me some Futurama and Bender.
Oh yeah, absolutely, yeah.
My favorite character. Oh my goodness. So, all right. So you're about to have to get out of here, right? So
Yeah.
about 10 minutes. I guess I'll just ask. Do you want to keep going, or
We can
you
keep
wanna just
going.
wap it up?
We can keep going if you want to.
Okay.
Yeah.
We'll
don't
go for a
stop
little bit
on my
longer.
account.
Okay. Cool. But so. Okay, I'm gonna ask you like a. I'm gonna try to ask you a good question here. All right. So, if you were to like really think about what it is you're actually doing with an engineering degree, like what is like to you like the real purpose of it?
Well, I was always raised to be like kind and intelligent, and so part of that is like giving back to the community and like helping others. And I knew from the outset that I would not cut it out in the medical field, going pre-med, going as a nurse or anything like that. So to me, an engineer is like the best career option because you get to help people maintain the current status quo, maintain utilities, maintain equipment, technology that is fundamental to everyone's daily lives, whether it's manufacturing phone cases, processors, helping line their houses with safe wires, because I have DIY'd my house enough to see like older houses.
Yeah.
Some of them are like, who made
Scary, dude. I live in
this?
a
How
old
is
house
this
too.
not burned down yet?
Yeah.
But it's helping people in a way that's interesting because it deals a lot with physics, and again, that's why I switched from being biomed into electrical engineering. It's just more engaging. And so I'm not choosing a career that I love, but I'm choosing one that I'm going to be interested in and I'm going to be fully engaged with for the rest of my life, really. Plus the paycheck ain't too bad.
Yeah. Yeah. So, I mean, do you feel like this semester you've gotten closer to that goal?
Well, yes, actually, because I'm getting done with my coursework. I'm getting better at time management because I feel like that's been a large part of one of the main things you learn in school. And you never stop learning it, little tips and tricks that, and like learning yourself too, because like I can do all-nighters. I don't function well doing that though.
Yeah, no. I have to be in bed. Like I have to get my 7-8 hours, dude. If not, like I've
actually found that I don't do good with 8 hours. I do best with 6.
Okay.
I'm jealous. I'm so jealous. I have to get at least 9.
Oh my gosh.
It's the worst.
9. Okay.
9 is, it's terrible.
Heck yeah.
I can't oversleep, otherwise I get just
Yeah, you feel a little groggy.
Oh yeah.
groggy. I yucky.
Yeah.
It's like the best term for it. I just feel gross.
Yeah, there's something about that, right? Like, so one of the things that I started intentionally doing this semester, right, was going into exams hungry.
Really?
Yeah.
I've heard that strategy.
And so they talk about how your brain actually functions better when you're hungry because it's sort of like it's in like a weird mode to survive, right?
Yeah.
And so whatever is like put in front of you that you feel like you have to survive, you just like you get after it. It benefits you.
Yeah. I can't eat before exams. I have found that if I don't eat prior, I get shaky and my thoughts get more muddled. So what I do is I actually like 4 or 5 hours beforehand, protein.
Okay.
Okay.
So like chicken sandwiches, I get like 2 or 3 of those.
Hell yeah.
For like, I get like a hefty brunch.
Yeah.
At like 11 or something. Like if my exam's in the evening, then I eat at 11. So then I have like 6 hours where like my glucose levels have peaked.
Yeah.
And because it's protein, they stay mostly steady.
Yeah, it's interesting because like, you know, as an engineer, for one, and really I think it's really good for everyone, but especially as an engineer because of the just tough computation we're having to do in these classes, right? And the types of memorization we're having to do with like math and you know, you have to have your mind sharp. If your mind is not sharp, like you might as well just go back to sleep.
I know, absolutely. I've had exams where I just blanked out during the exam, and after, even when I stayed in the room just doing the exam the entire time, it wouldn't even hurt if I just got up and left, because in the end I never got anything done, even staying no longer, because I just blanked out.
That's me exactly. I enjoy some of the homeworks because I get to play around with the problems and like understand them, but I am a horrible test taker. And so like I'll come in all prepared, all studied, all confident, and then I look at the problem like, what am I doing now? And so again, I'll just blank out, and so eventually you can only do so much on the exam, and then you're just like, I have 30 minutes left, but I cannot see myself doing anything with those 30 minutes.
Yeah. Well, I think that's why like I really tried to go through a test as fast as I can, because it shows me what I know. And for me, it's also like a sense of playfulness too. Like I like to. Now, I didn't get to do this a lot of my exams this semester, but I finally I got to do it for my last exams, which is sort of like I got to play around, right?
Yeah.
Like, and to me, that's when you're doing the best, when you've like try to study as hard as you can so that you can go into the exam and you can feel a little bit of playfulness, and so part of my playfulness is just seeing like what I can what I can recollect just right off the top of my head, and as fast as I can, and then I'll have to go back and have to think about a couple of problems here and there a little bit deeper, right?
Yeah. And that's what I do exactly. I go through each and every question at the very beginning, and I'll just read what it's about, jot down the basics of what I understand it's asking, and any equations that pop into my head that I can find. And then I'll move on to the next one and do it. And then I'll just take each one in parts, and as soon as I get stuck on it, I can't dwell on that. So I'll move on to the next one and do it again. And so like I kind of like go in sequence across them and finish them piecemeal. And then if I do complete one and I have time, I'll do it again. I'll try and see if I can solve it in a different method, because for all I know, I did it completely wrong.
Oh yeah, absolutely.
To begin with. So like on the DSB final, question 1, I overcomplicated. I know for a fact that I did, because I tried to solve it via the transforms from our table sheets that we did. And I ended up getting like this bizarre long equation for y of n, and I was like,
I'm trying to think, which one was that? For some reason, I can't think of what the first one was.
It was asking for the y of n.
I need to plug my phone in over here before it dies.
I'll love when they throw absolute heaters in for the first question, just to really throw you off.
Yeah,
That's hilarious.
so it just gives us h of omega, and it tells us find y of n from this.
Sorry.
And so you can see if I go to this page, I started it and I was like, oh, okay, so we'll just use the transforms, and I'll go from this and I'll take it to x of n, and then I'll use that, and then went down here and I'm like, the sign goes into this impulse, and then that gets there, and then eventually I'm like, okay, so I didn't have to take the integral of this. And I stop and I'm like, because that's nasty. And I go, okay, I'm just going to convert this to the Z transform and then take it to that.
So wait, what did you do?
This is what I did.
Here,
So you'll
go,
see
let
on
me
the
see
right
this.
side, I'm like, I'm going to use the definitions and our table to convert it.
No.
Exactly. I was going through it last night after the fact. I was like, I'm such an idiot. I overcomplicated it.
Yeah, you just
so
plug in
much.
that pi. You just plug in that pi,
Well-
because essentially what you're doing is you're looking at how h omega
Yeah, I know.
reacts to
I know
the
in
frequency
hindsight,
and
but
sine.
on the test, my mind was like, okay, we have omega and we have omega naught, and he's given
That's
us the value
hilarious.
for omega naught. And in my mind, I'm like, okay, so omega stays the same, because why would you have two separate variables if you're labeling them differently? Yeah.
That's hilarious.
Anyways, I gotta go.
So Connor, dude, thank you for doing this. Let's do it again sometime.
For sure.
To me, you're one of the most interesting people I know here at UCO. You always have some interesting
reach.
insight.
I've seen some.
I'm serious. I'm serious. That's why
I've met some people here. I'm just like, wow.
That's why I invited you to come here.
Imposter
And you're
syndrome.
you're very supportive of me and Physics Society, and
Physics is fun.
Physics is fun.
I enjoy having you around, man. And thank you for doing this.
Yeah.
Thank you.
Thanks for having me.
Yay. Good luck with your tutoring, or hopes for tutoring.
Thank you.
And let us
You
know how
got
that goes.
this.
Have a good day.
Yeah. Later, Connor.
You too, man, brother.
You want to take a... I gotta pee so bad.
Perfectly fine with me, brother.
Okay.
I'll hold your hand.
Okay,
Put that out.
I'll be right back.
Okay, it's fine. I always find it interesting, like this Saturn V missile system. I guess I'm the only one here now, so I can just talk about it. I can ramble on. No one can stop me. So the Saturn V rocket actually had a handmade computer, and they used textile workers to actually make the computer by hand. It was like microscopic little rings, and the direction of current would actually be what determines if it's a 0 or 1. It's the coolest thing ever. So a lot of what you see on the screen right here, like that one on the far right, it looks just like the modules used on the Saturn V. It's super cool. And there is a Smarter Everyday video It's a YouTube channel called Smarter Every Day. Engineer Destin goes to the Saturn V museum and talks to an engineer about an engineer who actually worked on it and how they made it. And it's just insane because it's these giant blocks of memory and computational power, and they make these all by hand, which is a microscope. I can only imagine the surgeon level precision you need to do that. It's very interesting. But in these giant blocks, like 5 kilobytes each, and these just like several of these together in different modules was all it took to take us to the moon. And that's crazy to think about it. In 1969, like I think 10 or 15 kilobytes was all we need to get the moon. And it's just insane. So imagine what we can do today.
Insane, dude. Let me see. Let me change the camera view now.
Yeah, I was just talking about the Saturn V.
No, that's totally cool.
Yeah.
I'm down for it. Can you push Connor's chair in?
Oh yeah.
Why is this? There we go. Okay, that should be good. And then I'll zoom in a little bit over here. Let's see, what is it? 11:47. We're an hour and 29 minutes. Let me write that down for our engineer. May have to. I won't take out what you said. Maybe just take out that I had to go pee.
Oh yeah, that's fine. Yeah, that's fine.
29. There we go.
In the part where I'm holding your hand.
Yeah. We don't want to put that in.
Yeah, we don't need to put that in.
I mean, we can if you want, if you're fine with that. I mean,
it's funny if you want to.
I don't mind. I'm fine with my sexuality here. We're good.
Yeah, Sydney, if you're watching this, it's just how it is.
Just the way
how
the road is. Yeah,
just the way of the road.
Just buds hanging out.
Exactly. 2 dudes hanging out.
Dude, thank you for doing this, Alex. I was
no problem. This is fun.
You were literally the first person that came to my mind.
Oh, really?
Yeah. I was like, who would be the most? Because typically, if we don't have a guest, it's just me and Albert, and me and Albert can just go off on
bounce back and forth. Albert's really very intelligent guy.
Yes,
Probably
and
one of
he
the most
knows
I've ever met.
so much.
Oh,
I'm just,
yeah.
like always.
He always has something that he can talk about related to the subject. It's insane how smart he is.
Yeah, and so whenever he said he wasn't going to be here, I kind of was like, well, I want to keep doing this, dude. I was like, so I gotta figure out who's going to be on, if I can get some people on, because I don't want to do it by myself. But by yourself is, I couldn't just sit here and ramble and talk to myself.
It's really hard to be able to do that. So
I mean, I think the only person that really does it good is Bill Burr.
Bill Burr and Theo Vaughn does it really good too.
Okay.
I don't know how that man can just ramble on for an hour and a half, but he does it, and it's always entertaining. It's really hard to do though. Really hard.
Yeah. Well, and then a lot of theirs is essentially a critique on social issues, right? Excuse me, where I'm trying to talk about physics, and it's just trying to sit here and talk through it by myself. I mean, I would love to maybe be able to do.
I mean, it's a great skill to have. It's just super. I think it takes time. And it's really hard to be able to do, and some people are just naturally able to do it better. That's just how it is.
And maybe it's weird. I don't know. I feel like it might be a little stale too. I love the back and forth.
Back and forth is really nice, and I love it a lot. Being able to go back because I don't even study like that. I study with people and only with people. I don't study by myself.
Do you mind? So the mic is right in front of your face at the moment. Do you mind bringing it down and then?
Yeah, like this.
Yeah. Okay. That's perfect.
Oh, that's my bad. I didn't even notice that.
No worries. Yeah. Our engineer gets lets us know.
No, that's fine. Yeah.
People want to see your expressions, Alex.
Oh yeah. Want to see my face?
But anyways, so let me just make sure everything's running just fine, really quick. Okay. So. I kind of want to ask you the same sort of question that I was asking Connor, which is I was watching this video last night before I went to bed, before we started watching our other shows, and it was Alan Watts. You ever heard of Alan Watts?
I have not.
So he's a philosopher, or I believe that's what you would call him. And so he has a bunch of these videos on YouTube, black and white videos of him just talking through sort of these philosophical questions of what does what does it mean to have a purpose? What does the word purpose mean? What is the meaning of the word meaning, right? And so it just got me thinking, like what does it mean to have like purpose, right? And so it made me want to ask you guys, like, did you choose engineering because you felt like you had a purpose, or it had a purpose, or do you get some type of purpose from it? Like, what is sort of your goal in like getting an engineering degree?
So my goal for getting an engineering degree has always been like, I love material science. I love that stuff.
Okay.
And so I was, ever since I got into engineering, like it's always been super rewarding. I've always had a lot of interests, but like never really like known what to specifically narrow it down onto. For a while, I was looking at like storm chasing. I always thought it was cool. I love storm chasing. I still want to be able to do it someday.
Do you do it? Have you done it?
I have not done it yet.
Okay, that's a crazy person thing to do.
It's just super cool. It's super cool because you're seeing physics, but like on like just atmospheric physics. It's super cool to see and understand how all that works. And we still don't understand how all that works. So we're still just trying to throw stuff in a tornado, and then get wind speed to see just how it forms. It's just really cool stuff like that. Just so many different interests. And then when I got this research opportunity, I never thought about going into research, but once I got this research opportunity, it's actually a weird story. Some random dude walked up to me in the middle of a lecture. It was one time I was doing like a virtual Zoom lecture because my professor's kid was sick. So just random dude walked up to me and was like, "Hi, I've seen you around, and I've talked to all your professors, and it looks like you're a pretty good student. Okay. So I want to give you my number so that we can discuss opportunities."
Oh, wow.
I thought it was a drug deal. I thought it was something related to like something drug related. It's like, okay, I'll shed lightly and we'll meet up in public.
Dude, that's awesome that somebody you're essentially
he was already looking
picked
for
you
me.
out of a crowd.
He picked me out of a crowd, and we met like a week later, and he slapped down his resume. And this man's resume is very stacked for an undergraduate, and he was like, "You want something like this?" And I'm like, "You got my attention." He got me into my IT position that I work here at UCO, just helping professors out, and he got me in the research position. The IT position helps me network with the professors here and to be able to get recommendation letters, and then the research helps me network elsewhere and actually get real-world skills and just other things put on a resume. And it's helped me so much. And initially I was like, the research is not, but it grew on me so much, and I feel like it's given me so much purpose and reward. It's so rewarding because there have been times like my first summer working research, I think it was summer of 2022, I had a lot of failure in the lab, and it was aggravating, and a lot of blood and sweat went into it, but when the thing worked, oh my gosh, the dopamine surge. It was insane. It's so rewarding just being able to put so much time into something and then see it work. It's just so cool. I made an oven. I made a little kiln out of a Yeti. It looks just like this.
Really?
So what I did was, in the top of the Yeti, I drilled a hole, and then I put a ceramic heater inside of it from a 3D printer, and then I put fans inside to kind of reduce the heat gradient that would stir up the air, and I would have an Arduino hooked up to it with a thermistor. Multiple thermistors that would give multiple temperature readings.
Thermistor?
Thermistor. It basically just measures. I think it's called a thermocouple. It just measures the temperature of something based on the resistance, the electrical resistance. It changes based on the temperature. So if you know at this temperature that it has this resistance in ohms, then you can predict other temperatures based on that, and they kind of like give you a curve on like the manufacturer like website on how it looks like to calculate it.
Like a RTD, like a resistive temperature device, Yep.
It's really cool. I put multiple of them in there at different levels just to make sure I could get like an average. And I would tell the Arduino to, with a relay, to trigger the ceramic heater on and off if it got within a certain temperature radius. So basically, I had made a vacuum sealed oven to heat treat my stents.
That's cool.
And it took a long time to get to work. It was really difficult, but it was so cool.
Cup?
Yeah, because I was like, I need something very, very, very well insulated so that it doesn't bleed any heat.
That's so
Obviously,
cool.
it's not perfect because it's got a plastic lid, but for what it was, it actually had a very consistent temperature, surprisingly enough. And
so cool.
it worked really well. but it still melted my stents because the ceramic heater was too hot for what I needed. My stents are made of polycaprolactone. It's a polymer, and as most polymers have, a very low melting temperature. So I was getting it up easily, like within 3D printing ranges is like 150 to like 250 Celsius for how most filaments melt. This one was way lower, like 60. So the ceramic heater, even with the fans and cooling it off and like just trying to vent air just to make it like a lower temperature, it still got too hot, and so it would melt the stents every single time. So I ended up having to scrap the project. Anyways, on a little bit of a tangent, but just kind of an example of something cool that I made in the lab and how rewarding it is to be able to say I made this stuff, and I actually got to make something super cool that worked really well. And I think that's what gives me my purpose, is to be able to just do stuff like that to help people and do stuff that I never thought I was able to do before. But now I'm just like, man, I got these opportunities, and I just get like free range in the lab to be able to find any method I want to solve an issue that my boss comes up to me with. And I think that's like the coolest thing ever. I think that's what gives me my purpose for engineering. What about you?
You know, it's really fascinating. Just for one, like where I am in my life right now. Like, if you would have looked back at who I was like 10 years ago, you'd have been like, "There's no way." Like,
that's what I thought too. Exactly what I thought.
And so it's just so wild, you know. So I grew up playing soccer.
Same.
Oh, for real?
I was a soccer referee before I got this job.
Go!
5 years as soccer referee and played soccer up until high school.
Nice. So I played competitive soccer all my life, mostly all my life. I played in some rec, like in very early stages of my life, and you know. I'm gonna share a lot about my life with you. All right?
That's fine. You know, that's perfectly fine.
So I've been thinking about this a lot lately because it's a pivotal point in my life when I was a kid. So I remember we had just played like an indoor game. And, you know, my parents weren't well off. You know, they both had like full-time jobs, worked really hard, and, you know, from just modest means, right? And so, you know, they were paying, you have to pay a lot to play soccer.
Oh, absolutely,
play any sport, right? You have like all the fees and things, traveling, right? And so at one point after a game, I guess I just wasn't having fun. I just wasn't doing well. And so I remember this like very clearly. We're like driving home after this game, and my parents are asking me like, is this something you really want to do? Like, you don't really seem to have like the passion for it, like you used to, or, and so I had to like, as a kid, I'm thinking like, my parents don't think I don't look like I'm having fun out there. Like, I thought I was having fun, and so I guess I just eventually told myself, like, okay, well, maybe you just need to give a little bit more effort, you know? And so I started, you know, trying to give more effort into it. I was like, instead of like jogging to things, I was sprinting to things. My mom used to get onto me all the time because I would just like walk to the ball or like just barely jog to the ball. And she's like, what?
That's funny.
And so, so it showed, but then I got like really good, and this team that was our rivals while I was playing rec, they came up to me after we had just lost to them in the state championship, and the coach is like, hey, you know, we're going to competitive next year. Would you want to join us?
Interesting.
And I was like, yeah, let's do it. But of course, it was more expensive, right?
Mm-hmm.
So that's whenever I had to like start getting a job and to help pay for all of this and everything, and so we're playing competitive soccer, we're killing it, we're winning like state championships, and then we get into the OPL, the Oklahoma Premier League, and we just start getting romped. But like I was only focused on soccer. Like soccer was the thing that I was like, this is what I want to do for the rest of my life, right?
Mm-hmm.
So all of this, what I'm doing right now, is like totally new to me.
Yeah.
And it feels weird, sort of, right? Like I honestly, I feel like my purpose was to be a professional soccer player, and I'm just having to like
let that go in a way. Yeah, it's weird, isn't it? You built your whole life around that.
Yeah, and so like, so the last time I played soccer, the last time competitively I played soccer was, so I was playing at Chickasha High School, and I got an offer from a little tiny school here in Bethany, Southwestern Christian University, and I was just pumped that like a college team was like, hey, we're gonna sign you, and we're not gonna pay a lot for your first year, but if you come in and you work hard, maybe we'll give you some more scholarship money and whatever. And not knowing anything about like college and things like that, because my mom went to college. She went to OCCC. But there wasn't like a big push in my family to like go to college. It was just like my parents were more or less like, just do what you think is the right thing to do. I mean, they felt like I should have an education.
Mm-hmm.
But they saw that I really loved soccer, so they were just like, do whatever you got to do to keep playing soccer.
Mm-hmm.
And so I ended up going to Southwestern Christian University, and was told, like, hey, you're probably not going to play your first year. And I was like, what?
Why are you signing me on if I'm not going to play? It's just,
yeah. And, because, like, whenever I played soccer, I was always either, like, the best player on the team or the best player on the field or, like, close to that, right?
Yeah.
So I was, I had a big head, right? I knew I was good, right? And so our first game that we play SNU, Southern Nazarene University, which is our across the street rivals.
Interesting.
Right?
Yeah.
And so the game is going all right. It's tied up. I think it's like 1-1. And it's like at the end of the game, I'm sitting on the bench having a good old time, just excited to be there, right? And one of our players gets hurt. And throughout that whole time up to that first game, like I was working my ass off, dude. I was the coach had nicknamed me the deer because I just like I could run, like I run on like the top of my what do you call it, like the palms of your feet.
Oh, like okay, like the balls of your feet.
Yeah, the balls of your feet. Yeah. And so and I was just I could just tell he was getting an interest in me because of just how hard I worked and the effort I put in. And so the player gets hurt, and at the time I was a striker. I was a defender like almost all of my competitive career, and then like at the end I ended up being a striker, just because I was the fastest person on the team, and I just had a mentality to go and score. And I could shoot from like 40 yards out and score. So, like I remember when I was a kid, one of my most memorable goals was against the Edmond team. I forget what they're called, like ESC or something like that. Yeah,
I think it's ESC.
I scored from half.
Oh,
dude, it was insane. And like at the time, there's this goalie that we hated the team because they were Edmond. We were essentially Southsiders, right?
Oh yeah, yeah.
And so we just looked at them as like little preppy Edmond kids or whatever. Yeah. And so we just always had this like rivalry against them. And I remember scoring from half, and the goalkeeper like ends up messing his foot up because he kicked the goalpost after I scored on him from half.
He got mad.
But anyway, so the ball's at half field, and I'm not even expecting coach to call on me, but he's like, Torres, get out there. I was like, all right,
Okay.
let's go. it's like the last minute of the game. I
Might
was
as well,
like,
yeah.
let's go. And so they have the ball, and they kick it. They pass it off, right, and we're going, right, and so I sprint towards that ball because the dude barely tapped the ball. I was like, that is the shit pass, dude. And so my instinct just go run straight to it.
Oh yeah.
And I slide tackle the guy and get the ball. And I've got
Nice.
the ball at my feet. I'm like, oh my god! I'm like I'm like at the their top of the circle, right?
Okay.
So I'm about like what, I don't know, 70 yards from the goal. I take like 2-3 steps, and I don't know what it was. It's not like I saw the keeper out or anything. I just had this instinct, like, shoot
Just
the
do
ball.
it. Yeah.
Just shoot the ball, dude. And I even had like a buddy next to me who was like, Josh, ball, 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 ball.
You try to pass it,
And
you're
he's
just,
like
yeah.
our leading, the guy who's ended up being like the leading scorer that year. I think so, anyways. And I just like was focused on the goal, and I was just like, fuck it. And I just shot that thing from like 40, 50 yards out, and it just goes right over the goalkeeper's fingers, dude, and into the back of the net. And then the right after that, the ref calls the game, and so I'm just like, just like so pumped.
That
Scored
is
the winning goal.
That's
against
amazing.
our like cross the street
Oh, yeah.
rivals, and like it was like one of the biggest goals I ever scored in my life. And it wasn't even a regular season game, dude. It was just like a preseason warm up or whatever. So that happens, right? And so I'm just like, okay, let's go. Like, this is my destiny, right? Next game, we're in Arkansas for a game, and yeah,
Arkansas, rip.
Which Arkansas is beautiful, dude.
It's a beautiful state.
But
People.
yeah.
Shout out to all my Arkansas people out there.
Yeah. So we're in Arkansas, and I'm just like, I didn't think I was gonna play. I'm just like, there for moral support and whatever. And like, not even like a minute into the game, like our forwards had a chance to kind of push and do something, but they didn't. It was kind of a shit play. It was, and so our coach saw that, and our coach was like very stern. Like he doesn't want you out there just like messing around. He wants you like
doing it.
Yeah, exactly.
Yeah, exactly. Yeah.
And so he pulled him and puts me in.
Oh, there we go. Okay.
I was like, what? I was like, I'm essentially starting the game.
Exactly,
I'm
yeah.
like, I'm a freshman, told I wasn't gonna play at all, and here I am, the first game, a minute in.
Yeah, just already playing.
And I'm getting
That's
told
amazing.
to get out there and go.
Yeah.
I was like, let's go.
That's
dude.
really good. That's really good.
So, I think this is literally the first play. I can't remember exactly if there was like a couple of things that happened, but I remember it as like essentially the first thing that happened when I was on the field. Our keeper has the ball, and our keeper could launch that thing, dude. And so he punts the heck out of that thing, and it's just me and the last defender.
Okay.
Yeah, and so
Perfect.
I'm zooming for the ball, right?
Yeah.
And I see the defender coming, and at that time, I had a killer instinct. I'm just like, I'm gonna get that ball. I'm gonna go score this thing, right? Me and the defender get to the ball at the same exact time, 50-50 ball, and he slides. Poof. And I hear this pop. There went my knee, dude, my left knee.
Oh my God.
I could feel the pop, dude, and I just knew immediately. I screamed the F word, which is kind of, I feel like I screamed it so loud of a pitch that nobody heard me for some reason.
Yeah.
Because afterwards I was like, did you guys hear me yell that? Like, because I remember distinctly, like, I said the F word really loud, and they were like, no, I don't think so. And I was like, really? I was like, did I just scream it so loud that like...
It was just, I guess, inaudible, weirdly enough.
But anyway,
It's like a deer whistle.
So I ended up, that lifted me off the field.
Was it dislocation? Broke? What was it?
Torn ACL.
Oh, God.
Yeah.
That's a lot of pain.
Yeah, and so that was the last time I played competitive soccer.
Damn.
Because I wasn't a student. I was a terrible student. I was like cheating my way through high school. You know, I was an athlete.
Yeah.
I was playing football, soccer, and track, right? And whenever you're an athlete in high school and like everybody knows like you're a good athlete, like
They're gonna let you slide.
hands off, like you can just
Do whatever.
Yeah, essentially.
Yeah.
Which I don't know is good or bad or whatever, you know. But it definitely allowed me to not be a good student,
Yeah.
and I just took advantage of it. Because I was like, I'm going to play a professional soccer, dude. Like,
Exactly.
I was all-state in football my first year. My senior year, I ended up kicking for the
Nice.
football team and like made every field goal. And so I went to All-State, or I was an All-Stater, and the coaches were like, "Hey, do you want us to put your video out there?" I was like, "You did really well this year. You're second in the state. You really should be first." But this other guy just kicked one longer field goal than you. And I was like, "No, I don't need you to do that. I'm going to go play professional soccer."
Exactly, yeah. I'm perfectly fine where I'm at. Yeah.
Yeah. Which now thinking back, I'm like, I should have done that, dude. Because what I could have done, it was like go kick at a big school, and then just walked on and played soccer possibly.
Yeah.
And just like milk the football thing.
Oh, yeah.
Because really, football's like where the money is, dude.
Oh,
Like,
yeah.
we were getting
Unfortunately.
free stuff all the time,
yeah.
free meals. Like we were getting breakfast, lunch, and dinner, like on game day, dude. It was insane. But so all this to say, like, so I made the decision to not play soccer anymore because I was like, I need to. I don't know what it was in me, but I was like, I need to go like live life or something. I need, and also like, whenever they did my knee, they took the patella tendon, and you know they essentially tell you like you're never going to be the same ever again. So in my head, I'm like, okay, I'm never going to be the same again. So I can never go and be that dude that I was on the field anymore. And I was so, I guess, caught up in that identity that I couldn't see myself being any other thing other than that type of soccer player where I'm just like balls to the wall, you know, sprint to every ball, faster than everybody else, you know, running around. So, you know, I could have probably, you know, people play with torn ACLs all the time. Well, not with torn, but like reconstructed ACLs all the time and do really well for themselves. And there's a lot of professional players out there that, you know, play with torn ACLs. So I look back and I'm like, oh my God, I totally made a mistake. all I needed to do was be a better student. I would have been just fine. But I chose really, you know, I thought that was going to be the harder route, was trying to figure out how to get better at soccer again, right? After that torn ACL. But really the harder path was the one that I took.
Yeah.
Which was like trying to go figure something else out. Because like honestly, for like a good chunk, dude, of years, I just like, I had no purpose. I had no direction. I had nothing. And then one day I was just like, I gotta do something. I gotta go back to school or something. I gotta figure this out. And I was just like, well, what am I gonna do? And I thought about going to the military because I was like thinking, okay, well, I love technology. Technology's cool. It'd be cool to work in technology. I was like, well, if I go join the military, I could probably just, you know, go do some schooling and go be in the military and work on some really cool technology, right? I was like, I don't know. The military doesn't sound too great, you know. I mean, I think it's a great path for a lot of people,
yeah.
right?
It's not a fit for everybody, and some people that are in the military, it's not always the best fit for them because you can tell, like they just want to say I was in the military, but they're not really having that much fun with it. They're not really enjoying themselves. It is an option. It's not for everyone, though.
Yeah, exactly. And my mom was always like, no, don't do that, don't do it. And so I'm like a mama's boy. I always listen to my mom, you know. So I was like, okay, let me figure out some other way. And some years passed, and finally, you know, I got into the situation where, okay, well, I'm broke enough that I could get Pell Grants. So I applied for some Pell Grants, and they were like, "Yep, you're good to go." And so I was like, "Okay, well, what am I gonna do?" And so I ended up signing up at Rose State. I was on like. What is that, like academic suspension, because my grades were so bad the first time I went to school that they were like, we're going to put you on this suspension.
Yikes. You're like, we don't really know about this one. So.
Yeah, and I think like you had to maintain a certain GPA, if not, like they essentially cut you, right?
Yeah.
And so I was like, well, this is like my last hurrah. So I was like, this is like I was like, if I don't do this, like, what else am I going to do? And so I ended up, you know, taking some classes, and I started to like it. I was like, I had to start like, I don't know if I think I started off remedial math. I think that's what it was, like algebra, some kind of algebra. And I was like, you know what, I kind of like this stuff. This is kind of interesting, right? And I started like reading a lot of the history behind like math and science, and I was coming up on taking my first physics course, and I read this book about like Newton and like some other physicists and like some of like the top inventions and breakthroughs because of physics, and I was like, okay, this physics thing is like really cool. And so I was like essentially taking like a associates in computer science. It's applied math, but they give you like courses that are going to help you go and get like a bachelor's computer science degree. Mm-hmm. So I thought I was going to come to UCO and get a computer science degree, but I was like, you know, I really love physics though. I want to be able to like apply these things that I'm learning in physics. And so I learned about engineering physics. So I was like, okay, well, I'm going to go be an engineering physics major. And then, you know, engineering physics, I think is a great degree, but it feels too broad. And I from what I've heard is, jobs look at it as very broad as well. And so I was like, okay, let me specify on something. Let me get a little bit more specific. So I was like, well, let's just do computer engineering. And there wasn't a lot of computer engineers, so it was kind of a weird, you know, talking to other people about it, because they were like, dude, it's not even A-Bet accredited. I'm like, wait, what? I signed up for something that's not even A-Bet accredited.
It is very new.
And then I started doing research, because I was like, you know, I'm getting through differential equations, and like I think I got an A in differential equations, and I was like,
can't say the same, folks.
And I just started to enjoy like just the challenge of it, and just like, but it started to become kind of not necessarily easy, but it was just like I had built up a formula, right? Mm-hmm. Like, okay, I know how to get A's and B's, right? I'm a good student finally. Right? But like that's something you have to learn to do. Like,
absolutely.
Like people say, oh, well, you're just born with this natural ability to be a student and learn things. I'm like, no, that is like, I think really is a learned thing. You have to learn. For one, you got to learn how to read.
Some people are just smarter than others, like naturally, but like in reality, no one's really much smarter than another person. Like no one's objectively smart. There's always something that you're going to know that I'm not, and vice versa. That's just how it is. But being a student is, like you said, that is completely something different. Mm-hmm. There is no just, you're born with the formula of being a student. Yeah. It's impossible with how like much work we have in engineering and all that. There's no way you just do all of that. Mm-hmm. Like you have to make a formula for yourself. Yeah. You have to know how to crunch time a certain way. You have to know, all right, this is how much sleep I need. How much of I really need. You never really realize how much sleep you really need until you get into college or until you get into a really stressful like work environment where you're like, okay, well I've got to ration my time so like razor thin margin that I have to actually know exactly how much sleep I need. I never knew that until college, how much sleep I needed.
Yeah.
Because I was working on really thin margins, and I had to learn to be a student. I had to stay up late and wake up tired and realize, oh, I need more sleep. I had to have those sleepless nights. to learn how to be a better student and learn what my body needs for me and learn what I need to do for my classes. And there is not really a formula that you can use for everybody. You have to kind of learn on your own what you need.
Yeah.
And so there's always a formula for you that you have to find.
Most definitely. Yeah. And so, I'd finally found my formula, right? Which is essentially just working hard.
Yeah.
Which is just making sure that so whenever I'm doing what I feel is my best, right? Is whenever I'm working on things so much that I'm waking up and thinking about a problem. And to me, that's fun. I'm just dude, I'm so pumped whenever I wake up and I'm thinking about a problem, because I'm just I feel like I have a purpose for the day to figure out how I'm going to solve this thing, right? But so I was I became this physics nerd, and which to me was just it's just insane, and I became to love math. I was like, what? I read this book by Edward Frankel, which is the love of math or something. Let me look it up really quick, because this is really I think a really great book. Oh, there we go. Where? Yeah, the Love and Math, the Heart of Hidden Reality. And this guy has a PhD in theoretical math or whatever it is, abstract math, or it's really a great book because he talks about all the things he had to go through to get reach his dream of becoming a mathematician. And he sort of breaks things down a little bit about math. He talks a lot about his life and everything, but he also talks a little bit about, why he thinks math is beautiful. And he does this by sort of talking through some mathematical ideas, and, and he talks about how, the math that we think of is not the math that the guys at the top are thinking of, right?
Yeah. Absolutely not.
It's on a different level.
Oh yeah.
And so I always just seeing the new level, right? I love knowing that I'm just at the cusp. I'm really, it's funny because I'll show my girlfriend some math problems that I'm working on. She's like, how does this even fit into your head? And I'm like, this is a simple one. And so it's just there's definitely levels, right? Yeah. But then I always love finding that there's another one. Or there's one that's multiple levels ahead of where I even am. Oh yeah. Because it's just it's that challenge, right? It's that for me in soccer, it was winning, right? Whereas in academia, for me, it's the challenge is learning new concepts, and it's not even the test really. It's just my ability, just reaching that new level of conceptual understanding of how the universe works. But so I take a class, modern physics. And it was Dr. Lamachani's first semester, and he was his first day. He was like, "Hey, I'm here to do research. We're doing material science research. Anybody who wants to sign up, I can't pay you at first, but he was like, but the school is really excited about this, and they're going to invest in us." And I was like, I'm just barely getting by anyways right now, so I might as well. And I never really think about money. To me, it's what do I really want to do?
Exactly. It shouldn't be about money, because you can make all the money in the world, and if you don't really like what you do, and you don't enjoy what you do on a day-to-day basis, it's not going to make a difference.
Yeah, there's a lot of, and I get it, right? A lot of people choose engineering because of the
money
promise of the yellow brick road to the big bucks, right? But so I was like, this is a new challenge. This is really my currency. Is a new challenge, right? And so I started doing research, and you know, I love when you find out that a thing isn't like as like mystical as you think it is. Because at first, when you think about research, you think about like Feynman, you think about Oppenheimer, you think about
these brilliant individuals. Then you're like, oh, there's no way I can even square up to them in any way or capacity.
Yeah, but you know, I always thought Einstein was bullshitting whenever he said this. And it's the quote that I try to live by, which is, I have no special talent, I'm only passionately curious. And then he also even goes on to say, like, you know, I don't believe I'm a genius. He got called a genius all the time, right? But he was like, I don't see myself as a genius. I see just myself as someone who has spent more time than other people with the problem. And so I just started taking that more seriously. Like, okay, I've shown that I can learn shown myself I can learn new things. So I can do this new thing, right? You just gotta take it slowly. And what you learn in research is that it's, you know, like for instance, like ChatGPT, it looks like a huge like it just happened out of nowhere, and that it was just like this big breakthrough that like was out of nowhere, but really it was like years and years. Like they've been thinking about the perceptron, which was like the first like neural network where just one neuron, and that was like in the 1920s or 1930s.
Interesting.
Yeah.
I didn't even realize it was that far back that we made one of those.
Yeah. And then it was like Jan LeCun and his work with, I believe it was neural networks, in looking at handwritten digits. Like that was back in the 70s.
Interesting.
When he had made that breakthrough, and then I think it was like the early 2008, 2010, something like that, where guys up in Toronto were figuring out like how to look at images, how to process images with neural networks, and like and then they built the transformer, and then had to be so many, you know, we're on like ChatGPT 5.2 now, right?
I know, it's crazy.
The first one sucked.
Oh yeah. The first one of anything is gonna suck.
Yeah, but so I try to take things more serious, like more like okay, research is just like learning new things and then trying to make incremental progress where you can.
Yeah.
And it's great that I have a great advisor that's sort of like, it's like, hey, like what are you interested in? And let's find you a project for that. So, you know, I was like, well, machine learning sounds cool. I want to get
so cool.
Yeah,
it's so cool.
I want to get into that. And he was like, okay, well, let's put you on this project where you're using these classification models to classify whether something is magnetic or not magnetic. And then, you know, that's sort of that project keeps getting bigger and bigger, and hopefully it's funny because everybody's like, oh my god, you excited for the break? I'm like, yes, I'm excited for the break, but in sort of a different way.
Yeah.
Like no, I'm not going to be really taking a break. I'm going to be like really pounding some research, and hopefully I can get things the way that I want them to, so I can start really finishing up our paper so that I can publish before I graduate with my bachelor's, so that hopefully I can say, hey, look, you know,
I did this.
published.
Yes.
Now pay me for my master's.
Yes.
So yeah, and research has just opened up so many doors, and it's like repurposed my life almost. And I wouldn't say it's just research. It's the things that I learned along the way of like, well, a challenge can be anything. It doesn't just have to be based around athletics, right? I mean, to me, that's my favorite. But like at the same time, we have to be realistic about our lives, right? Like, you know, I'm 34 now, dude. So I'm like, for me to get back into soccer is like, it's just crazy talk.
Yeah, in terms of like sports, you're like an old man. You're ancient. Yeah, you're already aged out of that.
Yeah, but you know, then I think about like Descartes. I've been reading a lot of Descartes lately, and he didn't publish his meditations, which is what he's known for, until he was like in his 40s or something.
Yeah.
So I'm like, okay, let's go.
There's still time. There's still time.
But yeah, so that's, long story long, is like, it's interesting because the reason why I wanted to just say that is because I've never really spoken that out loud, right? I mean, I have to like my girlfriend and my parents know and everything, but I think a lot of people, I don't know really how they perceive me, but I want people to know that like this is hard work. Like I try to make it look easy.
And you do that pretty well, I will say. You do make a lot of your research and just like, because I mean, I've sat in your lab a bunch of times just like looking at what you do and like the 2 monitors that you have, and it's like, oh my God.
3 monitors.
3 monitors now. Thank the Lord for 3 monitors. It's just it's a lot. It's something that, I mean, it also doesn't help that I'm not familiar with it. So obviously it's going to look more abstract to me because I don't really deal with machine learning for what I do.
Yeah.
But it's really insane work what you do.
It's
and
fine.
I'm just going to say I'm proud of you, man.
Oh, thanks,
I
dude.
always see you, because I also work a lot on breaks.
Yeah.
And I will come back by Hall if we got something up in IT, and your door is always open.
Yeah.
Into 157, and you're always in there.
Yeah.
And you're just like me. We're always here. We just love what we do, and you have a drive for it that I wish more people had. You really, I can tell just by how like happy you are. I can tell you love what you do.
Dude, I appreciate that, and it's one of the reasons why I asked you to. You were the first one to. I know I said this earlier.
Well, if you need any more help, if you need any more guests, I would love to be here.
Okay, cool.
This is fun.
Yeah, it really is fun.
Yeah.
And we've talked a lot, but we've never really like sat down and like.
Exactly. Yeah. Because I mean, we talked a lot about a lot of things, but it's good to have it hashed out like right here, and we can just have our own little space. Where we can just get all our ideas and everything that like makes us just out there.
Yeah, and you kind of like what I was talking about earlier is like we don't really, especially as engineers, right? People who are really building the future, right? We need to be thinking about implication.
Oh, absolutely.
We need to be thinking about all of these different aspects of what it means to be an engineer, not just for ourselves, but like for the world.
The world, everything we do has an impact, and so I think it's very important to just not look at just what we want to do and what we love to do, but like we're gonna influence people. So how are we doing that?
Yeah.
You really need to look in the mirror every morning and think about how what I'm doing is going to help other people. That's the most important thing.
Yeah, because I just wish more people thought more deeply about things. And this isn't, I don't think it's anybody's really like fault, right? I think I think a lot of it is just how you were brought up, right? Like, look at me, for instance. It took me a long time to get to where I am now, where I'm like able to, to try and think deeply about things, right? To be curious enough to think deeply about things. And I think part of the reason why I want to like bring in as many people as we can to talk to is because I want to know, like, where does curiosity come from? Because for me, it wasn't easy. Not at all. And, someone like Albert, who, man, is like one of my favorite people in the world.
He is extremely very, very curious.
He's been like that since he was a little kid.
Yep.
And I'm like, but I think his dad was an engineer. I believe so. So I'm sure that rubbed off.
A lot of it is just like nature versus nurture, and that's that whole argument of like, if your dad's really curious and your parents are really curious and they push you that way, I feel like obviously you're going to be curious.
Yeah.
But then there's people like you who just became curious, and it was kind of like more of a nature thing.
Just like a process.
Yeah, it's a process. Everyone. That's one thing I really love hearing your story is that we all come to the same place and have different formulas of getting here, and so and obviously at different times. So it's not like life is a race.
Whoa! Obviously, I never thought. I was messing with you.
Yeah. It's fine. Yeah. I mean, you're 34. I'm 23.
Yeah.
But there's no race to it. We're both enjoying the ride, and obviously you had fun doing soccer. You loved it. You love what you did, and I wish I spent more time on sports because I love sports. And so a lot of people like to compare to like each other, like, oh, you know, I'm older and I'm younger, or blah blah blah. But in reality, we're all getting to the same place, doing the same thing we love. And I feel like we need to think more deeply about like just that, and just stop worrying about just like where I'm at on my trajectory. Yes, because in the end, we're gonna get there anyway.
Yeah, it makes that, what you just said, makes me think of a question I get quite a bit is, so what do you need to make on your final to get the grade you want? I'm like, that doesn't, to me, I don't sit around and like think about my grades.
Exactly, yeah.
I just
do it. I
try to just do my best to understand the material, and if I fail, or if I fail the class, right? Like, I don't look at that as really a failure. I mean, it hurts, yes.
It definitely hurts. There's no way. We're not gonna lie to you and say that it doesn't hurt.
No, it definitely hurts, man. You know, I ended up not passing my first class since coming back to school in the spring semester, and I had to retake that class over the summer. So like, it almost like broke me, dude. I was like, wait, what? You know, because like I'm a natural competitor, right?
Exactly.
I was born, I feel like, to compete. I just love competition. And, you know, I love competing with myself. I think that's like what has like changed my sense of like, just like it's made me a happier person for one. Just like not trying to compete with other people, because that can really get under your.
It really messes with you.
Yeah, it does, dude. Like,
it really messes with you.
I find myself like, you know, like they used to say that like, or they say that Michael Jordan used to like create these rivalries in his head with people, and I've done that before. I've found myself doing that, and I'm like, what are you doing?
Exactly. I mean,
it's interesting though, because it does fuel you in a way, but it also like it can make you angry.
Anything, just like anything, it can push you way too far, and then you get egotistical, and then when something does happen where you inevitably fail, because everyone's gonna have a failure point at some point. When it does happen, you really take it to heart, like, man, I'm not good enough. Man, am I really gonna be able to finish where I started? And that's bad. I mean, anything to that extreme is bad. It's like, but I feel like it needs to happen to some people, and it needs to happen to all of us, that we learn from that, though, that there is just our journey, and that there isn't really, we can't really be so focused and tunnel visioned on that of, I'm gonna get this done my way, you know, and
I think
not fail.
Focus, you know, to me, I was just thinking about it last night or this morning. I was like, because I yesterday I got asked this question, like, you know, well, what grade do you need to make on the final? And I was like, you know, I was just thinking about it later on. I was like, to me, that's like being an engineer for the money.
Yeah.
And it's like, because it's like this, it's this empty goal, I feel like, is an A. I mean, of course, you know, I want A's and B's, right?
But what does that mean?
Yeah, I mean, honestly, to me, what A's and B's mean to me is that you're not trying hard enough. You're not doing enough. You're not stretching yourself enough. Because, I mean, especially in the beginning, like whenever you're first going to school, like a lot of the classes are pretty chill. Like,
absolutely.
I mean, algebra. Of course, if you put the block on your mind and you say, I'm not good at math, like it's going to be hard.
Yeah.
But if you take that block off and you say, I can do whatever I can do, like algebra is one of the easiest classes. And so is like philosophy and like Comp 1 and Comp 2.
Yeah.
I mean, they make you think, right? But it's not like differential equations.
Yeah.
It's not like signals and systems, right?
Definitely not. Oh my gosh.
Where it's not just the coursework, but it's also the professor. Like that's
absolutely.
tough, right?
Yeah.
Nothing against that. I just it's just tough. But yeah, so yes, I'm doing probably too much this semester, and I'm definitely going to claw that back a little bit next semester. But I've learned a lot about myself through just the heartache of like realizing, I did do my I decided to do way too much this semester, but I found out like, okay, I know exactly what the things are that I do want to keep doing, like this podcast. I want to keep doing this. I want to keep talking to interesting people, right? Trying to figure out more about myself, more about the universe, more about the people around me, because I really believe like the most interesting people are the ones right around you.
Oh yeah.
Because I am constantly shown that here in this podcast. Like I've brought on people who I barely know, but like we always have this interesting and fun conversation, and it's just always fun. So I'm like, okay, let's keep doing this. I love Physics Society. I love leading a team. I love trying to inspire people. There was like this person who said like, what does a leader actually do? It's like, well, it inspires and gives hope to the people they're around. And like, I've always wanted to do that, right? And so I enjoy doing that, but there are little things that I don't need to keep doing. Like I wanted to, and I may still do this, but like I've been wanting to put together like a list of all the research going on in, but it's really hard to do, right? There's just, it's just one of those things that it's like, does it really need to happen? Like maybe I can just go and talk to people and see the research. There's got to be an easier way, right? Like I know Michael Springer, who's the guy of
OHIP, Office of High Impact Practices. He's the president of that.
OHIP. Yeah. Like I bet he's got a list of everybody who's doing research. He's got to, right? So maybe I just need to go talk to him instead of trying to go talk to every department and seeing like, so maybe thinking just smarter about things.
There's more people here than you think that are doing technical research. So the definition of research. I think I got an email because I'm going to Incur. I think you got the email too of how many abstracts were submitted.
Oh, you are? I thought it was like January and you had to. Because you have to apply and then they tell you in January, right? If you're going or not?
You're pretty much going.
Oh, okay.
I mean, because I thought like, because 99% of the people get accepted.
Okay.
I mean, the only time I think they limit
That's
people.
most conferences you find out.
Yeah. I initially thought, this is very selective, but it's really not as selective as some other conferences. So you'll probably be going. I'll be going.
Yeah.
Some of the boys will be going.
Yeah, let's go.
It's going to be fun.
Yeah. Virginia, here we come.
Oh, exactly, yeah.
Have you been?
This is my, I think, hold on, my count. 1, 2. I think it's my fourth one.
Wow,
my fourth Incur, yeah.
Dude, that's what.
My fourth Incur.
And so that's what I love about you. You've been doing research longer than I have.
Yeah, I've been doing research since I was a freshman.
Yeah, that's dope.
The most cool thing and what really solidified me in research was I got published when I was a freshman.
Okay.
Because they were already working on a paper, and I did, apparently, everything I did during my summer was enough to include in the paper and really help out and solidify our project.
Wow,
that was the coolest thing. So if you look up my name, you just look up Alex Matseko, you're going to find NIH published paper. It's the weirdest thing. It's so cool. It's weird looking up my name, though, and seeing that.
Have you gone to Google Scholar and looked yourself up?
I think so.
Yeah.
And I also get these weird emails from people asking for me to like publish in their journal or something like that. They ask, they say, Dr. Matseko. I'm like, I'm not there yet. That's flattering. It's super flattering. Let's go. It's just cool stuff like that. It's just like being able to go do stuff like that. It's the coolest thing ever.
Yeah. So like, I don't know. I love traveling. I love seeing new places. Right. Like we went to Palm Beach recently, Palm Beach, Florida, and it is like one of the most majestic places I've ever been in my
yeah.
life. The beach isn't as great as I thought it was going to be, right? It's kind of, I mean, there's definitely sand. There's the ocean. I think any ocean is beautiful, but there are some that are more beautiful, right?
Oh, absolutely, yeah.
But like, cause I've been to Destin, and Destin was like, the sand was like white, and the ocean was blue, dude. It was like the darkest blue I've seen in the ocean, and this was like kind of murky waters. I don't know, maybe it was this time of year or
You're just
whatever.
near an oil spill or something like that.
And the beach was like, it was like a little bit of sand. It wasn't like a big, like, where I was, now maybe you could go up and down a little bit further, but I went up and down pretty far, and it was still the same, but, it was pretty scary because it was high tide, and
Had a dog with broken Heineken bottles and needles you're gonna step on. And,
yeah, it was kind of trashy, I'm not gonna lie, which is kind of crazy because in general, it was the cleanest place I've ever been to in my life.
Interesting.
Like, they have people walking around, picking up trash throughout the day. But the buildings there that are like right on the ocean, and the houses, oh my God, dude, the most beautiful houses I've seen in person ever in my life. Like, you could smell the money in the air, dude.
It was palpable.
Yeah.
It was there, and you could smell it.
Yes, dude. It was like, man, you saw these like big, I want to say like, maybe not cement. They're probably like some kind of rock, that they use to build these buildings. But they were some of the most beautiful, and like, you could tell that they could withstand a hurricane.
Oh, absolutely,
dude. They
yeah.
were just like meaty buildings, right? And just beautiful too.
Yeah.
And what was so weird about there, right, was that I always make sure I wake up every morning and work out. I just have to. It's just the only way that I feel like I'm like ready for the day. So I woke up at 5 o'clock that first morning we were there, and I went for a run. And I don't typically run. I typically get on like a stationary bike, but I was like, I'm running to the beach, dude. I'm going to the beach. I don't care what anybody says. I'm going to the beach. And I'm running to the beach, and the beach is like a mile and a half from our hotel. And it's just one big road. You go over this bridge, and then you get into this like business district area. It's got these buildings that I was talking about that are beautiful. And then there's the ocean. And what was the weirdest thing ever is like, I saw nobody.
No one was there.
Nobody, dude. I literally, the whole way there, see nobody.
That's odd.
Dude, is it not?
It's like in a post-apocalyptic world.
Dude, in Oklahoma City, you get up at 5 in the morning, you hear honks, you hear like,
honks, people,
ambulance go.
you see people driving by with the only free finger they have out the window, waving it at you.
Yeah, people walking their dogs and stuff.
Oh yeah, it's aggressive any time of day.
It was so weird. And then the beach was like closed. I didn't know that you could close a beach.
I only know they do that whenever it's like there's like a shark sighting or something like that. I don't know of them just.
Yeah, no, they
having a curfew.
They had this big old cement wall that goes all the way up and down the beach, and these like locked gates, right? But
Lock the gates.
I'm not gonna lie, I jumped the gates that morning, and I got onto the beach. One of the most like. Because not only did I not see anybody there, and it's like the sun's still not up, not even close to being up either. It's like pitch black outside. And you ever heard of liminal spaces?
Yes.
That's what it felt like. It felt like
Interesting, yeah.
It felt like there was like this weird. There's just this weird feeling in the air. It was really strange because I was like, how is there nobody out here? This place is beautiful.
I know, right?
The weather was amazing.
This is a beach, an oceanfront beach, and you're telling me I saw nobody after running
and there's all these businesses around, and there's houses there close to that area too. So I was like, how is there nobody driving around?
Surely someone's gonna be going to a business to open it up in a few hours.
No, dude. So I'm on the beach, and I'm not gonna lie, I was like scared. Because I was like, for one, I was like, well, I mean, it seems like there's like nobody out here, so there's nobody even gonna mug me, right? Like, and I didn't have anything on me either. I just had my phone and my I was wearing shoes to run, right? And so I'm sitting there on the beach, and I'm just like looking out in the ocean. It's just like pitch black, and I'm just like, dude, this is scary. And so I was like, I took my shoes off, and like I touched the water, but as soon as my feet touched the water, it's like this, just like shock went up my body. I was like, dude, I gotta get the fuck out of here.
Yeah, gotta get out of here. Yeah.
Yeah, it was so weird, so eerie. And so I got out of there, and I run back, and I saw a cop. And then finally some people started showing up, and like some cars started driving, but it's like, this is weird. Like, nobody gets up at 5 a.m.
I guess not.
Yeah.
Which is weird.
Yeah. I also kind of felt like a badass too. I was like, I'm the only one.
I'm the only one. I'm the patient zero of waking up today. Yeah.
But yeah, so, you know, you go and travel, and, you know, I learned on my first couple of conferences that, like, well, you know, you go to your first conference and you're just so excited, right? You're like, and then you feel like you have to be there the whole time. You have to, and then you like my first one was APS Dallas, and like, so it's not like a only, you know, there's different kinds of conferences. Some that are like very specific to a certain, like for instance, we go to a magnetics conference we've been going every semester now. That's the one that was in Palm Beach. And so that one's like for magnets. Like, we just nerd out about magnets. So it's like, anything about the leading research in magnets, right? Or you go to the APS, which is American Physics Society, right? And so there's so many different topics. There's like cosmology, astronomy, you know, quantum mechanics, quantum computing, material science, all types of, you know, you name it. And if it's physics related, it's there. And so that was my first, and so I was just like, okay, I was a sponge, you know. I'm just like, I'm going to be
soaking it all up.
Yeah, I'm just going to go to try to be in every one, and then I didn't really get to experience. I mean, I've been to Dallas before, so it was like, whatever. But I was like, you know, I'm going to make it a point, though, and the next one's like, I want to go and, like, see the place. And so we went to New Orleans, which was so dope. So I was like making sure, like, getting up at 5 o'clock every morning and like going out and like just seeing the town. I did the same thing in Palm Beach, and I just like, I was in Palm Beach. I was like, and hopefully nobody is that was paying for us to be there is listening.
This never happened. This is all in a video game.
But like one day, I was just like, dude, I'd hit a wall. I was like, I can't go into another talk. I'm just like, I'm talked out. Like, my brain is checked out. And so I just went and just like walked around Palm Beach, dude, just like for hours, probably like 5 or 7 hours, just walked around, and just like, there's like so much history there too. So it's just like, you know, because you hear about these people going to places, like comedians, for instance. They go to places and they never really experience them. So they're just like, oh, I can't wait till I can just go and vacation there or whatever. Yeah. I'm just like, no, I got to experience it while I'm there. Because you never know, you may not go back, right?
Exactly, yeah. I'm not going back to LA. I'll tell you that right now.
You're not?
I'm not going back to LA. I almost got shot twice when I was in LA.
What, really?
Almost got shot twice, yes. Some guy, when we were taking public transport, I don't advise that. If you can rent a car, that would be the best case scenario. But if you're not 25 or you're not married, they're probably not going to accept you to rent a car. So what do? You ride public transport. And well, it's LA. They got plenty of public transport.
Yeah.
But you're seeing a lot of sketchy people in public transport a lot. When we took the tram, because we were wanting to take a tram because we were in, I think, I don't remember the name of the beach, Long Beach. We were in Long Beach, and we were trying to take a tram to the city. Because that's my philosophy is, while I'm there, I like to be at the conference a lot, you know, get to network people, but I like to see the city, and that's what I like to do. And so me and my friend Wei at the time were always doing that. Well, me and Wei were wanting to go downtown to like the Asian district to get some like really cool like Chinese or Asian food. Yeah. And when we were on our way there, well, obviously it took a while because we're taking stops every like quarter mile. There's tons of stops. This dude randomly came on and just screamed, "I'm gonna shoot this bitch up!" And me and Wei got off that one. Wait till the next one. Like, we'll take your word for it. We're not risking that. And then we got off. Okay, this one was late at night. We got off of the tram at 2 a.m. We were going to see what restaurants were open. And as soon as we crossed by to this Denny's that was over here. Some crackhead comes around the corner, and what looks like he's holding a gun, and it sounds like he's shooting at us. Like, it was really loud. I've been around firearms all my life, so it sounds like a gunshot. It was very loud, and so we just took off running to the Denny's, and through the window we were like, call 911, call 911. And they called the police for us, and the police showed up, and the guy was already like running off by the time he saw the lights, and we were just inside. We weren't planning on getting Denny's, but well, we were stuck inside. We weren't about to go back outside, so we got food at Denny's that night.
Heck yeah.
And then what was
I used to work at Denny's.
You used to work at Denny's?
No, I bet IHOP.
I'll ask about that in a second.
Okay.
I bet you guys have good stories about that. I don't know why it's every breakfast place. Anyways.
Yeah.
When we got there, we ordered food, and we explained our situation, and the waitress looks at us and just says, "Welcome to Long Beach. This is a regular occurrence." So like, okay. Yeah, so needless to say, it wasn't the best city for me. I'm not really a big city person after that trip. We went to the Hollywood Strip, which was nice, and it was really beautiful. But there was just a lot of people, tons of people, no matter what time of day. It was like 11 o'clock at night. They were still flooding the Strip, and it wasn't like a weeknight, too. I just didn't feel as comfortable with it. And that's just a me thing, I think.
Oh, definitely.
And then with my obvious experience of almost getting shot twice, I won't be going back there. But I do not regret going on the city. I think it's a beautiful place, going to Santa Monica Beach, the most beautiful place. And then we walked up to Griffith Observatory. Beautiful place. Absolutely beautiful. And I recommend anyone who goes to LA to see, and if they're there for a conference, to make the most of it. Just go around, because there's so many different things in different parts of LA. You can really just get a good taste of a little bit of everything. Like, the Asian district is beautiful at night. Griffith Observatory is beautiful at night. And just being on, because the Griffith Observatory, if you know kind of like the topography and the geography of the area.
Shit during the day, I guess.
It's, obviously complete dog shit during the day. Don't waste your time, yeah. But at night, because it's on top of the mountains, like behind the Hollywood sign, it's beautiful seeing the city lights at night. It's so beautiful. It's like seeing the stars. It's just beautiful. And so being up there at night is just amazing. Yeah. But it's one of those places that I probably won't go back to again. But I made the most of it, and I do not regret ever going there. So this IHOP thing, tell me about that. You're working at IHOP. It sounds interesting.
You know, I wish I could say it was interesting. I'll be honest, I was a terrible waiter.
Oh, yeah?
Terrible waiter. I just hated it, honestly. I mean, I love people.
Yeah.
So that's sort of what like helped me get through it. But it was just sort of one of those things like, I needed a job, right?
Yeah.
And so, and I was like tired of working in warehouses, and so I was like, let me try this IHOP out. They're hiring or whatever, and I had worked as a waiter in St. Louis. At this pasta house, and I hated it then, so I don't know why I was like, you know what, let me just go work this IHOP.
Give her a shot. And IHOP, too, of all places.
Yeah.
I want to give it a shot. It's like walking at Waffle House. Oh my god.
I don't know, I guess I just thought like, people are always talking about like good tips and stuff like that, and like you can live off tips, you'll be fine. And this was the IHOP right off of Northwest Expressway by Penn Square Mall, so I was like thinking, it's probably busy all the time.
It's a pretty good area, too.
Yeah. But, like, I don't know. I just have always had this thing in me that I was like, I'm meant to do more meaningful things, right? And so IHOP was one of those things that was almost like... Not against anybody that works at IHOP. It just, for me, it was like so soul crushing, because you just people. So one of my bosses said something to me that really stuck with me. It was like, of course they're not nice to you. They're hungry.
Interesting.
Yeah, and so. Like, nobody is their best self when they're hungry.
I never thought about that. That's completely true.
Yeah, and I was just like, well, why do I want to be around a bunch of hangry people, right? So yeah, I don't know. I mean, like I said, I love people, but I don't know. You just and maybe this was just IHOP, right? Or actually, it was. I've worked at multiple restaurants, so I know it's not
Could be
just
just
IHOP. But it's like I don't know. I don't like serving people like that, I guess, is what it is. I like getting to know people. I like meeting people when they're not hungry.
Yeah, because when they're hangry, they're not really wanting to explain themselves. They just want to get the food. So
yeah,
it's not a very welcoming environment, I would say.
No, it's not. And IHOP is kind of. It just call it as it is, right? It's sort of a low-end place, right? So people aren't going there and like putting down $100 tips.
Oh yeah, no,
or
absolutely
whatever.
not. They're going there, and they're not they're not there to get to know you. They're there to you give me food or I give you a knife, and that's just how it is.
Yeah, exactly. But it was a good learning experience. I learned a lot about myself there because I learned I don't like being a waiter. That's for sure. And it just I think it just was more kindle on the fire for myself to get my shit together. I was like, because I was at a time in my life where I just didn't know. I didn't have any direction. I couldn't find my purpose, right? So that's why I'm just so pumped where I am in my life right now, because I feel like I actually have and it's weird because I was watching this Alan Watts thing last night, and he said that without purposelessness, there is no purpose.
I agree with that, and I think it's the same thing for good and evil. If you don't know evil, then you don't know good. You need to know. And do you regret working at IHOP?
No,
Exactly.
I wouldn't say regret.
You were talking about man, I hated it. I hated it so much, but you don't regret it because you learned such an impactful thing about yourself.
Mm-hmm.
And I think that's what's important. You need to be purposeless at some point to understand to be able to be purposeful.
Mm-hmm.
I feel like you need it, and then it really helps get drive.
Yeah. And, apparently, what Alan Watts was trying to explain is that, in Western society, we look at purpose differently than, they do in the East. I mean, it's kind of crazy how you have, Eastern philosophy and Western philosophy, and they seem like two different things. But, and I wish I could have finished the video, but essentially he was saying that Eastern philosophy looks at purposelessness differently than we do. They almost look at it as if there has to be purposelessness, whereas here we look at purposelessness as what he was saying was like a cuss word. It's like a negative thing.
Oh yeah.
Right? To have purposelessness, to be purposeless. But in Eastern philosophy, they look at it as a good thing. They look at it as this thing that, it's like that yin and yang thing, right? You have to have both.
You have to have both. You have to have both.
Because too much of one thing,
Yes.
is not good. So yeah, man, it's just so weird. Life in general to me, and dude, I'm just so grateful. I'm just grateful I'm alive, honestly.
I am too, man. I am too.
And I'm just so pumped that I found this other thing that I really enjoy, which is really just learning.
Yeah.
Learning about how the universe works to me is gives me my purpose. I don't even really think about it as it's going to help me gain money. Right. Yeah. I mean, I know that I can probably monetize it in some way down the road, right? But I'm just, I think to me, trying to understand the universe is really the most interesting thing in the world. Because I'm just the more we understand about how the universe works, the more we understand about ourselves, the more that we can not in a bad way, but we can take advantage of that, right? We can see that like maybe I feel purposeless right now, but what I do know is that like there's seasons, right? And that things can change.
Oh, absolutely,
right?
and they will change.
We see different equations, maps change,
Yeah.
right? So we know change can happen. You
Yep.
just have to apply a certain force to it
Exactly.
in order for that to happen. And so maybe you're just not applying the right force.
In early life, it's just about finding that force and applying it the right way.
Yeah. So what do you think you got most out of this semester?
I think this semester was definitely my easier semester in a while, and it has helped me to kind of, I guess, reflect on other semesters. And so probably what I got the most out of the semester was just learning about my work ethic from previous semesters. I could have definitely put more work I could have definitely put more time into it. I could have put way more of just everything into it, and I chose not to. Definitely procrastinating things.
Yeah.
Well, I mean, that's the thing you can say about every semester. I mean, I have definitely gotten a lot better at procrastinating. But
You got better at procrastinating?
obviously, yeah, I got better at waiting until the absolute last minute. Obviously, so.
What do you think that is? Is that because maybe you got better at certain things, so you're able to?
I feel like, it kind of goes hand in hand. I feel like the more you know, the easier it is to procrastinate. It's weird.
Yeah.
But especially now when we have AI, it's a lot easier to procrastinate. That's all I'm going to say. And I will and can represent everyone by saying that.
No, for real.
It's so easy just to like learn more in a shorter period of time and to speed up. Like writing papers, for example. It's so much easier now just to speed up the whole rough draft process. So now I can, instead of waiting till the day of, I can wait till 2 hours before it's due. And I can still get it done and still have a somewhat relatively quality piece of paper, or just anything I can throw out there and submit. But I feel like just being a lot further down the road has helped me be able to procrastinate more, and that's obviously worse for me. And so looking back, just this whole semester has been easier for me, and it has caused me to procrastinate more. I feel like.
So how do you think you're going to mitigate that? Or are you going to try to?
I'm definitely going to try to mitigate that. Next semester, I'm doing heat transfer, which is debatably one of the hardest, if not, I don't know, it's debatably the hardest class for mechanical engineers at UCO. And the professor is a little bit more stern and very, some would say, what's the word? Just very like to the point, just very like there, and he wants you to really get the stuff done a certain way, and he will not be relaxed on you at all. And so next semester with that, then mechatronics with Musa, Dr. Musa, that's gonna be fun.
I might be in there with you.
You might be in there with me?
Yeah.
Yeah, it's gonna be an interesting semester.
Oh, so it's going to be Musa, huh? Mechatronics?
I think it'll be Alamari
Okay.
teaching the lecture, and then it's going to be Musa teaching the lab.
I'll be honest, I'm trying to get out of that class. I'm trying to figure out if like my solid state devices course can cover that,
Yeah.
because I just took that because Dr. Lamachani wanted me to, and because I was like, let's do it. Like it's an exciting class. And then or there's like IoT apparently you can take that possibly.
That's new. Alkerm is doing that one. That's a new class.
Yeah.
That one I think should cover it for you if anything.
Yeah.
So I can't imagine why you would have to take mechatronics if you're going to take both those classes.
Yeah, I don't know. I just always I've kind of heard it's a blow off class, and I'll be honest, like I know inside of me that I'm just not going to appreciate that.
Yeah.
I know some people have to take it, right?
Yeah.
But if I cannot take it by taking another class, I'm like, let's do that.
Yeah.
And nothing against. I don't know. I don't know. I just have heard mixed reviews on that course, so I'm just
on
like.
mechatronics?
Yeah.
Oh, absolutely. Yeah, it's definitely like. more electrical and coding focused, I would say. They call it mechatronics, and on paper it's supposed to be like the integration of electrical with mechanical. In reality, it's just mostly building robotics circuits and then
with
coding.
your own money.
Yeah,
Not with the school's money, which
so
is like, what?
That's the thing. I've already spent like $100 into this IME design project I'm working on. They require this project, and there's no funding for it. So
See, that's ridiculous. So, Dr. Lamachani, Tej, for solid state devices, he got money from the school to pay for our project.
see, that's how it should be.
But Tej, one of the hardest working
absolutely.
mofos I know.
Absolutely.
Dude. So I'm sure it probably took a while and had to figure out some way to pay for it, and maybe just other people aren't willing to put that in. I don't know. I just know that apparently you had to pay for mechatronics, whereas I didn't have to in solid state devices, and that's a brand new course.
Exactly.
This was the first semester, so I'm like,
it's ridiculous.
Yeah.
We have to pay for that. So I already paid like what, $1,000 for this course or whatever, and now that doesn't even include the fact that I'm required to do a project. It's not required to pass the course, but it's usually a big enough part of your grade, and you're not doing good enough that you can just bypass it.
Yeah. So that's my main rub with the
pretty
course.
much required, and you still have to pay for it.
Yeah.
What the hell?
I don't know, dude. I don't know, man. I don't know. We're coming up on 3 hours. Is there anything else you want to talk about?
I'm not sure. I mean, I didn't really go into this with like, what do I really want to talk about? Because I felt like you already had like a guiding point, and so I was kind of just. I'm willing to talk about anything if there's anything else you want to talk about.
And that's what I wanted. I wanted you guys to just be able to show up. I didn't want it to feel like work to you guys.
Yeah.
Because that was my biggest fear was like, and I think a couple people I reached out to maybe felt like that's what it was going to be, like some kind of work thing. But I'm just like, no, like just have fun.
It is fun. It's relaxing. It's not something that I love having conversations with people. I love being able to just talk. And
so that's what's been kind of fun about this, right? Is that so all of our other podcasts have been very like this is the topic, and we try to adhere to that topic as much as we can, right? We try to talk through that topic as much as we can. So I do a lot of like research for it, and I get like a week to essentially research it. So it's been fun, like just seeing for one how much I can learn in a week about a topic that I've never
never even considered before.
Like last week's was the physics of music, which is this is a huge rabbit hole.
I didn't even think about that, but that sounds like a massive rabbit hole.
Oh my god! I now want to play the piano, and I'm just like, oh, when am I gonna find time? And I want to get into music because like there's this weird. I want to be more creative. I've been, I used to be, soccer was my thing that I was like, it was like an intellectual and creativity thing. And so I've been just trying to find that. And I know like people are like, well, research is creative. And I'm just like, well, I haven't really gotten to that point where I can feel like I'm be creative. I still feel like I need to learn a little bit more, but like, and of course music's going to be like that as well. But I just want to get into something that feels like purely creative, like drawing. I tried drawing, but I get kind of bored, and it
takes a lot of patience.
I end up just doing scribbles.
Exactly.
And I'm just but do you have something like that you're like you feel like you're creative with? Like, do you do music or anything like that?
So I used to do music in high school, but I kind of grew out of that. I think my creativity outlet was engineering. I did a pre-engineering thing at a Votech that was partnered with our school. I really loved it, and they kind of just gave us a project, but they gave us all the tools. Obviously, we had to learn it first before I could get creative. But once I got to that point, it was the coolest thing ever. I just felt like it was a good, easy, creative outlet for me just to be able to do stuff like that. And even with my research project now, I feel like it's a good creative outlet for me because Dr. Hassan doesn't really like basically bottle feed you everything. He just tells you exactly what he wants done, and he doesn't care how you get there. Obviously, unless it costs like $1 trillion, he doesn't care how you get there. And so I feel like that's my creative outlet. It's just being able to go in the lab like during winter break, which is exactly what I'll be doing. And you'll see me there.
Let's go.
Is just going in and really thinking about the different ideas that he wants from me, and coming up with my own ideas of how I want to approach that, and just getting glassware out, getting different things out, all these different scrap materials and processors, and just throwing them all together and see what I can do, just see what I can make, to see if it'll work where I'm trying to get, and that's what I like to do.
Hell yeah, dude. I love that. I don't know. For me, I'm just like, I guess I'm really bad at comparing myself to like people who I think are great, right? Because I want to be great, right? And so a lot of the greats were like, they were philosophers, they were musicians, they were mathematicians, they were, natural philosophers, they were, politicians, like, and so like, I think and in this like thread of trying to understand the universe, I'm just like, I feel like I need to like try all those different things, right? For one, to just like explore my own curiosity, right? And two, like just learning about music, and just the complexity of it. That's, to me, that's what's interesting. It's like complexity of things. Oh yeah. And so it's like this, I'm just like addicted to challenges or something. So I'm just like, I need a new challenge, I like seeing how fast I can pick something up, right? And yeah, I don't know. I've always thought about, I don't know, playing some type of music. I have a guitar that I never play, but to me a piano sounds cool.
I've always wanted to play the piano, but I just never had, because I feel like of all the instruments, that one takes more time to learn.
UCO has pianos you can play up on the 4th floor.
Yeah, I was about to say, because I remember them, and you can just put the headphones on and you can just play the piano, and they have it all the time. And I see people playing the piano, and it's just like, man, I wish I could do that.
I think that's going to be one of the things that I try to do over the... Because I know I'm going to be up here a lot, and I'm just like, maybe I'll just try to go over there for like the last hour of me being up here and just play around with it. I don't know. But, yeah. So, but, I think this is really a fun, creative thing to do, too. It's just like, I don't think people think about, like, talking as being this weird, creative thing.
I feel like it definitely is.
It's got to be, right? Like, you think of, like... I think of like some of the best speakers ever, like Lincoln or like Obama. And you name it, right? Martin Luther King, right? They had such a way of talking that was like mesmerizing.
Oh yeah, it's not just like, it's like putting words a certain way is art.
Yeah.
Because we have like obviously just tons of different words in the English language, but like just how you piece them together is its own creative art form. I mean, that's why you have writing, that's why you have speaking, but talking even helps you just rationalize your thoughts, and sometimes just getting it out there, something you've never done before. Maybe there's like for example, your story just about like your soccer and like you kind of like how that evolved, something that you don't really get out there very much. Just something like that, just getting it out there can help you rationalize, like, and remind yourself of something like, oh man, I came this far, and maybe you took it for granted, and then now you're reminding yourself. So like just talking, I feel like should be its own creative outlet, just helping you think critically about what words you choose to use a certain way for how to convey your messages. I feel like that is its own outlet.
Yeah, I know I say this all the time, but I love saying it. I just do, because I feel such a connection to it, of like things seem really great in your head. There's like, you have this mental picture of things in your head, and you're just like, man, that's so cool, and I'm like so hip to that. That's totally who I am, and then you start to speak that thing out, or even like these interesting and complex concepts that we talk about in class, and you have this picture of them in your head, and then you go to try to speak them, and you're like, I don't know what to say. Right?
Exactly, yeah.
And you're like, oh, like,
there's a barrier there.
There's something different about that, right? There's maybe I don't really understand it in the way that I thought I did, right? Or sometimes I say things, out loud that I like. For instance, I like joking around with my girlfriend. Right? I say some of the most ridiculous things around my girlfriend, just because I try to get her to laugh, and I love comedy, and So, I was like, oh my God, this is going to be so funny. And I go to say it, and I'm like,
It's not that funny. It's not that funny. That happens all the time. You win some, you lose some. And sometimes you have some absolute misses, and you're like, okay, yeah, no.
I love that. It's so funny because it's like, why do some things land and some things don't? It's like, is it because maybe you have thought through that thing a little bit more than this other thing?
Maybe there's just some context that you thought was like common knowledge. It's not.
Yeah.
Never know.
Yeah. But anyway, so what do you got going on for us today?
Rest of the day, I'm going to be working on my ME design project. It's due at 5.
Oh, shit.
I'm going to be working on that the rest of the day. I don't have too much left, but I've got enough left that it's like, okay, that's what I'm going to spend my time on.
Okay,
and then trying to fit in the gym because they changed, I didn't know they were going to change the hours and shorten them for finals week for the gym.
Really?
I went there last night at 9 because they usually close at 10, and they apparently closed at 8. So I needed to work out yesterday. That pissed me off.
Yeah.
But today they're closing at 5.
Okay.
So, you got to get stuff. Aren't you lucky? That is not fair.
Every morning, dude.
Yeah, dude, I would love to be able to do that.
Home gym is where it's at.
Home gym is where
I know not everybody can do it because it's not cheap, dude. But
it's not.
You gotta make the investment, though. Man. You gotta invest in your body and your brain.
Exactly. Yeah.
Okay. Yeah, I'm going to the me and my girlfriend every last day of the fall semester, we go to the Nutcracker.
That's cool.
Yeah. So I'm so pumped. We didn't go last year, so I'm just like super excited for it this year.
That's cool.
And we like dress up and there's something about the story of the Nutcracker that I don't know. I just feel like a connection with the music, the orchestra, and that's another thing. I'm sorry, I'm going to get you out of here. I swear.
You're fine. I love this. This is fun.
But you don't think about it though. But so when doing the research for this last podcast, so of course, like if you think about a piano, right? Like whenever you play 2 notes at the same time, they have to mesh well with each other. They have to be able to sound correct, what they call consonant together. Yeah. And some notes sound dissonance when you play them together. So if you think about it, orchestra has to be like one of the most hard things to do ever in the world because you have all these different instruments.
More things that can go wrong.
And all of them
mesh perfectly.
Yes, dude. I'm just like, oh my God, I didn't even think about that. And the way that a clarinet sounds and the notes that it makes is totally different than what like a trombone does.
Oh, yeah.
So you have to make sure that these things mesh well.
But then you got like humidity and temperature that affect the reed and the tuning. Just 10-degree difference in temperature, and you have a completely terrible song.
Yeah, so that's why, dude. I'm so pumped that you said yes today because I was like, man, I'm honestly like addicted to this.
No, this is fun.
I love it.
I can see why you're addicted to this. This is great.
Yeah, because I get to talk to my girlfriend and stuff like that, and of course I have conversations in the lab and stuff with people, but I never get to sit down for like 3 hours and
really get it out there. Yeah. See, I wish I could do this more often.
Yeah,
because it's great.
Yeah. Well, dude, if you want to come on again, let's pick a topic.
Yeah.
I'll give you as long as you need. Maybe over the break, if you have like something you've been wanting to dive into, physics related, of course, which everything is.
Yeah, everything's physics related.
Like even if it's like related to your research, something that you already know a lot about, but you just want to come in and you want to talk about it. Like I'm totally down. Like I love exploring new ideas. So if it's something new that I've never heard of, I'm totally down to dive into it. Because I think the more ideas I have going on in my head, I think the better I am at just looking at things in general, right? Feel free to shoot me a text or whatever and say, hey, this is the topic I think I want to talk about, and then we can just schedule it and come in and do it, dude.
Go from there.
We typically do it. It's been every Friday typically. We've missed some Fridays here and there, but then I think 10 o'clock is a good start. We've been starting around like noon and things like and 1 because of people's schedule. So if there's like a schedule thing, just let me know. I'm totally down to do this again with you, man. It's been fun.
No problem. Absolutely, man.
But anyways, like I said, we like to end every podcast with a clap well, we say until next time and then a clap. So until
Next time.
let's go.
Let's go.
Awesome.